Hello everyone, very good morning. Good morning, Nahid. Um, am I audible? Can I get a quick confirmation, please? Also, I'm going to share my screen. Hey, hi Bharat. Mm, so is my screen visible and okay? Thanks, Sachin. Perfect. Okay. Thank you. Let me also open the timer. Okay. What else do we need? Okay, let's start the timer. What happened? Don't know what happened. Okay. Fine. Let's wait for one more minute for people to join. Meanwhile, let me do the speed test. Okay. Okay, looks fine. So meanwhile, we'll talk about agenda as well. Basically, I wanted to talk about the siege attack that we have done yesterday, right? So you remember, right? We had created a load balancer, and then we had two types of backends to that. Um, one was in US, one was in Europe, right? So, and then for as the traffic was going to the closest region, right? As the traffic was going to the closest region here, yeah, not here, this one, right? All the traffic was going here. That's why we created one siege VM. We did some stress testing. We sent around concurrent 250 packets we had sent to this one so that this get overloaded and then right so that our traffic goes to Europe as well, right? So what happens is this siege, like sieging or whatever is the stress testing that we try to perform using the siege tool. It's basically, uh, I would say, kind of seen it as a malicious activity, right? Because that's a very common DDoS attack that hackers perform, right? They try to send so many requests so that the the servers in the back end of any website or something gets crashed or get hanged, right? So what happened is, um, I got a mail yesterday from Google Cloud, okay, that my project, the project in which we were working, was for committing the denial of service DDoS attack. It was suspended, right? So, and also that I mean, this had happened earlier also. So what we can do is we can submit an appeal in this, just by clicking this one. It will open up some one single simple form where you can just specify a reason why you did that, right? Or was that intentional? Was that a uh, you know um, what we were you basically what were the reasons why we were trying the that way, right? So I just provided them. I had submitted an appeal yesterday, right? But then it is basically random. For I mean, I have seen this. This doesn't happen all the time, but uh, yesterday and one more time it had happened with me. But that time when I submitted the appeal, right, that time it was resumed back, whereas I got an reply later after 2 3 hours that as per the further analysis by Google, this project will remain closed due to violation of so and so things. Okay, so I mean, just be careful, right? So if you are doing this, since it's a free trial account and it's just the one project, okay, don't worry too much. So let's say what I'm trying to say is, let me close this, the console that we have, right? So we had three projects, right? We were working in this one, and the other two projects we did. You remember we did VPN connectivity, hybrid connectivity, and all, right? So, and at any point of time, you can still create new project also. That's fine. For your free trial account, you still have lot of quota, around 25 projects you can create in your account, right? So we already have other projects also. So I'm going to use the GCP project from today onwards, but this particular project is being suspended. Okay, so it's again I'm getting a request appeal page here. I can just give a reason or something. But yeah, so it we already got a appeals response, right? So that's fine. So let's go to GCP project, and then for practice you can just create a new project. If you don't have, just create another one and then continue in that one if you get this error. If you don't want to try out sieging and all, that's fine as well. That's not a problem. Okay, so I just wanted to make you aware on that as well. But I mean, it's nothing to be worried. Okay, it's not that. Just wanted to inform that what had happened on this particular account, so that you are just aware. Okay, so now today's topic would be all around storage services. We'll see. First of all, we'll understand what type of data, what type of storage services that we have, why we need those services. Okay, what are the different offerings that we have in GCP? Some introduction, let's say, and then we'll jump on to the different offerings or the different services that use based on the use cases. We may choose either cloud storage or cloud SQL, Spanner, Firestore, big table, memory store, and file store, right? So, and at the last we'll also see when to choose what based on some use case or some tree structure. We'll understand when to choose what are the conditions for choosing any particular service, right? It may not be a single solution for all the use cases, as you say, right? So we'll see which one fits where, right? So then let's get started with the introduction. One sec. Okay. So first of all, like, now you already aware, right? Or if you're already coming from an IT or computer background, so now we already know, even if you are not, then also we know that the data is growing so fast. Like, we have so many smart devices, IoT devices coming in, right? So these are all we have so many websites, portals, right? We have now mobile devices, on that also we have apps, right? So there are so many different types of sources of generating the data, right? Every company is generating the data for their users, from their users, and that works like a fuel for them, right? Because of some meaningful information they want to take out of that data, or they want to process the data, right? So based on that, it's like a new business, right? It's like a fuel for their business, right? So now with that data, first of all, if you want to process it, or if you want to uh, any find out any meaningful information out of it, if you want to do some any artificial intelligence or machine learning kind of jobs on that, right? If you want to come up with some predictive analysis on that data, right? You need some processing, but in order to have, in order to perform any processing on top of data, at least you need to first store it, right? You need some storage service or a storage system where you can dump that data. Then only your job can connect with that and it can process that data, right? So depending upon different what I can say, the business requirement or the your use case, your solutions would be different. Okay, so the sources that we were talking about, right? So sources can be different types for your data. Sorry, for your data, there can be different sources. What happened? One second. Like it can be your business data. It can be media streams, right? Like some like audio contents, video contents, like some media streams, right? Then it can be sensitive data. These are different what I can say, forms forms of data. Okay, then the data can be sensitive, insensitive, like that also we can categorize, right? Then data can be from sensor based or IoT based, IoT database, right? So whatever are the smartphone devices or any smart other like scanners or anything like that, so they create the IoT data as well. And some websites create stream logs, right? So whatever the log activities gets, being performed by the user, they create the logs out of it, right? So all that pattern, all the user patterns, all the different types of activities that user do, that is also kind of considered as a data, right? So there are different forms of data, right? Now depending upon your uh, you know um, depending upon different types of data, your solution, of course, as I said, that can be different. So let's say for type can be again under that relational, it can be relational or non-relational, right? Structured or unstructured, right? So you can, this might be people might be aware about relational, non-relational, right? So you can store that data as a table, right? Row columns kind of thing, or it can be some files which is not relational, non-structured. It can be semi-structured also, right? Like JSON, XML, right? So different types of data is there. Then different sources, as I said, right? So it can be devices, it can come from devices, or it can be coming from apps or software applications on your laptop or any other smart devices as well, right? Now the data may have a different purpose, right? Sensitive and non-sensitive, right? So we can have different types of classification basically, right? It's not that the data can be categorized only in a certain way. Depending upon type, we can categorize in a different way. Depending upon the source, we can categorize in a different way. Depending upon what type of data it is or the purpose of the data, is it a sensitive data or insensitive data, we can categorize in that way also. So there are different ways in which we can categorize, right? So depending upon all this combination of whatever the data we have, we can classify. And then depending upon the answer that we get, let's say we have a sensitive data, we have a relational sensitive data, then our solution will be different. If we have unstructured data, okay, and it is we need that for some website or gaming perspective, then my solution will be different, right? So depending upon the classification and your business need, your target storage service can be different. So GCP, I should say your GCP storage service can be different, right? Depending upon what type of data and classification that you have, right? Using these different questions, right? So depending upon that, your solution would be different in GCP, right? Why it is important? Why it is important to have a proper solution or the proper answer for our question. So which is the proper or the best storage service suitable for my use case? Why this particular question is important is because you need faster results. Let's say, let me write it, and then faster results we can say, enhanced performance we can say, and cost efficiency. So why we need to spend time and why we need to decide the perfect storage service, that out of these whatever I have mentioned, why it is important to choose the perfect one for our use case is because you want to get a faster results for your data, right? So uh, let's say you have selected relational database, right? So let's say you have selected something like MySQL or PostgreSQL, right, which has relational database which stores the data in table and rows and columns, right? You can still store your let's say a text file in relational database also, like a blob storage. You can use a blob data type and you can store the file, but that is that efficient? No, it is not. So because the relational database will take a lot of time for such blob storage fields, right? So the what is the next best solution that we have? The best solution for such files, because it's an unstructured file, right? The file maybe a video file or an audio file, you cannot store that in your relational database. So the best solution for such cases would be something like cloud storage that we had seen multiple times earlier also, right? So we can upload a video, or we can upload an audio file in the cloud storage. So that can be, like, based on our need, we'll have to select the proper storage service so that we get a faster results, so that we get a better performance to our jobs, right? So unless and until you configure the proper solution, you will not get proper or enhanced performance for your data retrieval, right? Then the next one is the cost efficiency. What do I mean by cost efficiency is, as an architect, it is okay or it is good to ask some question. Based on the answers to those questions, based on the business requirements, you need to understand, based on those answer to those business requirements, if you understand the business needs correctly, then it is always better to spend more time on this analysis rather than choosing a wrong storage service and then spending time later point of time that okay, this solution doesn't fit to my project, right? So you should not be at that particular spot that a later point of time in the project you feel that okay, this is not working for us, right? This is slowing down the performance. Now then the discussion comes and okay, comes out to be that it the solution, the storage solution that you had provided as an architect wasn't the best solution, right? So yes, at times it might happen, but you know to have a proper cost efficiency of your project, you need to spend some time during the design and analysis phase of the project itself to understand all the business needs, right? And based on the business need, you need to come up with the best storage solution for that particular project, right? So that's how you can effectively manage your cost of your project also, right? If you end up choosing a wrong storage solution, right, then it will be a lot of rework, a lot of costing will be added costing to your project estimations, right? So that's how it is, that's why it is very important to choose the proper storage service. Okay, so now what are the different storage services that we have? Let me take this diagram. Okay, so if you see here, we have different storage services. Okay, and there is some categorization as well. So you see here, so if you see here, object storage, file storage, relational databases, non-relational databases, and data warehouse, right? So based on your business need, if they are looking for a data warehouse, you will go for BigQuery, right? However, we are going to park this for today, right? We are going to cover rest of them, okay? So if your business need is to have a relational database, they already have a relational database on their on-premise, let's say, and they want to stick to that, then you can go for either of these two. Now, uh, uh, out of these two, which one to choose, that's another question. But then the first question would be, if they have some file system which they want to migrate, like some shared network drive or something, then file store is your solution in GCP. If they are looking for some object storage file system, then you have object storage object based storage system, then your solution will be cloud storage, right? Similarly, if they are looking for some non-relational database, right, so it can be Firestore, or it can be Bigtable, right? So depending upon your use case, these different GCP storage services that we have, we'll see them one by one now. But and we'll park BigQuery for the another module, right? That will be covered in big data analytics. I'll cover that in big data analytics. Okay, but we'll see the rest of them. So now, if we talk about the first one, what is cloud storage? By now we have already seen multiple times how to create a bucket and all, right, in different demos or something. But yeah, so cloud storage, basically it's a So before we jump on to the cloud storage, what we can say here is, the first question is whether your data is, maybe what I can say, to be stored as data or under tables, right? Is it relational, basically, or not relational? It should be structured. Is it structured? If your data, right? Whether your data whether your data is structured or unstructured, right? If it is unstructured, then you can go for the file or object based solution. Okay, so if your data is unstructured, if unstructured, then your solution could be file or object. If it is uh, uh, if your data, input data, is a structured data, right, then you don't need to put it into a cloud storage or a file store, right? You can directly dump that into the cloud SQL or cloud spanner, right, if you see in this particular diagram. So depending upon what type of data that you have to first choose this one. So cloud storage is basically an object storage solution. What do I mean by object, right? It's not a First of all, let's say it's not a file system and not a block system also. Okay, it's not a file storage system that you generally have HDD and SSD, right? But it's not block storage system also. Okay, but it's basically called as object storage. Okay, what is object? It's an arbitrary sequence of bytes. Okay, it stores the data in a sequence of byte format. Okay, it doesn't create a like a physical or a logical blocks of your storage system like you have on your hard drives, right? It doesn't work that way. It's what it does is, it basically creates a sequence of those bytes of your file, and then it internally stores onto their storage service or their storage system. right? Everything is considered as by object here. Everything is object. What do I mean by everything is object is, even though you can still create some folders, you can see some when we'll come to the we'll go to the console, right? You will see we can create folders, we can create folders inside the folders, and we can dump the files in different subfolders also. You can see that structure just like you do on your laptop, right? But it's considered as an object. Okay, even the folder itself or the subfolder is also an object. It is not uh, it's not considered as a folder there. It is considered as an individual object. That folder, let's say one folder has 5 files, then that particular folder itself is an object which points to 5 other files, or not files, 5 other objects again. So everything is object. Okay, even the folder and the files both are considered as objects, and they have unique identifier that is called as URL of the that particular file. Okay, so whatever you upload, that will have its URL, right? Using that URL, Google Cloud understand which object you are basically referring to, right? Then there is no minimum capacity or fees required. What do I mean by this? Basically, cloud storage, you don't have to, okay, so Google does not ask you for any storage capacity. Let's say when you create a VM, we need to attach a persistent disk, right? To that we select for, let's say, 10 GB, right? So your VM can only store the data in that persistent disk, and the capacity is 10 GB, right? So that particular capacity is already allocated to you, and even though you don't store any data on that, you already pay for that 10 GB of persistent disk storage. Here in cloud storage, let's say, they do not ask you for any minimum or any capacity, right? You just start from the first day itself, you just start dumping the data, right? Whatever the data you store in your cloud storage, only that will be charged. Okay, so let's say you just created a one bucket and you just dumped one single file of 1 GB, right? So you will be only charged for that 1 GB, and you don't have to specify, okay, what is my maximum capacity I want 5 TB of space. No, it can it can scale to exabytes also. Okay, so scaling up to exabytes is possible. Okay, so but you don't have to specify any minimum capacity. Okay, that this is the capacity that I'm looking for. Okay, so it's not something like reservation that you need to do. You just start storing the data as you do, without worrying about what is the maximum limit. They do not ask you for capacity. They do not charge you for any minimum fees. Let's say you just created a bucket, empty bucket, it won't cost you anything. Okay, so there is no minimum fees will be required, because you are not reserving any resource. Okay, we are just trying to use the storage, whatever the storage you use, right? Whatever storage you use, you only pay for that. Only you pay for that much. Okay, whatever, let's say you stored 5 TB of data for your project, you will only have to pay for 5 TB of data, right? Hexabytes means it's if you don't know about hexabytes, is basically um, it's like GBs. GB everyone knows. Then we have terabytes, right? Then we have petabytes, and then we have exabytes. Okay, so it's like this. So how can I put this relation is 1024 GBs or petabytes equals to 1 hexabyte. Okay, that's the relation. Now you need to understand 1024 petabytes is 1 exabyte. Similarly, 1024 terabytes is 1 petabytes, and 1024 gigabytes GBs is nothing but 1 TB. So you can imagine how big is the storage system that Google has, or they propose, right? So you can even go to exabytes of data. They have that much of capacity with them. Okay. So these objects again, one more point is immutable. Okay. So basically, you cannot edit or you cannot modify your data on the cloud storage directly on the cloud storage, right? You can do that, but you have to on the cloud storage, once it is comes to a cloud storage, then that object is immutable. Let's say you have a file that has some data, you want to edit that file, right? Then you have to have some let's say you have to download, edit it, and then upload it, and while uploading you can override the existing file, right? That way it is modifiable. But as an object, right, it creates another object on top of that when you overwrite something, right? So it's basically overwriting that particular object but not modifying it in the place, right? That's how objects are always immutable in cloud storage. Okay. Then we have certain features also. We can have it at regional, dual regional, and multi-regional. Can be created for regional, dual regional, and multi-regional. This is also called as uh, redundancy. Okay. So basically, you can create a cloud storage bucket as a regional bucket. Okay. So the copies of that particular data that you store in that cloud storage will only be residing on the data centers of that region. You can, at the same time, you can also select your bucket to be dual regional. So what will happen is the copies of your data will be created in another region that you choose. Okay. And in multi-region, it can be an entire continent that you can select, and you can have your data to be stored in different regions, multiple regions of that continent, and that will be automatically be done. You don't have to select which regions in that continent I have to choose. It will be automatically chosen by GCP. So it's basically kind of a backup of your data. If your data is critical that you don't want a single copy of your data, then you can go for dual or multi-region also, right? And you can also get high availability with that. So depending upon your region, whatever is the closest one, it can be served from that particular region to your your system, downstream system. So then it supports retention policy. Some features like retention policy, it supports versioning. We'll come to this, we'll see this in action also. And it also supports life cycle management. Okay, what do I mean by retention policy? Let's say I need to take, let's say you created this cloud storage and there is this file. Okay, you uploaded this file here, okay, on the cloud storage. This is let's say GCS, Google Cloud Storage. Okay, and this is GCP project that you have. So you have uploaded this file here, right? Now you want certain kind of a lock on this, right? On this particular bucket, that nobody should be able to modify it, nobody should be able to delete the file once this file comes. So if you want certain kind of lock on your bucket, then you can have retention policy. Okay, so what you can do is, let's say you can specify that for 7 days nobody should be able to delete anything from this. So as soon as the file comes in this particular GCS bucket, that file will stay. It will be like, you should be able to access, you will be able to access that, but nobody will be able to delete that file because of the retention policy. Okay, Then you have something called as versioning. What is versioning? So let's say this file was then modified. This file was modified locally, and then when you store it, right, again, let's say you overwrite it. So because it can be only in the same bucket, you can only store that once, right? So what you will do, you will overwrite the file. So you have modified the file in a way, right? Technically you have modified the file on GCS, but you can have GCS to have, let's say this is file, the name of the file is file.txt. So you can have, let's say, #1, and you can have file.txt #v2, v1 and v2. Okay, so you can have keep multiple versions of the same file. Okay, when you fire ls command, let's say I want to see the how many files are there, it will show only one file, that is file.txt, which is the, let's say this is the latest version, it will always show the latest version by default. But internally it will also store the versioning. If you keep this on, if you keep this versioning on, it will also keep a older version also. You can specify how many old versions you want to keep. Okay, but by default it will show only the latest version, but you can still access the older version also. So there will be some different command for that, which I'll show you. But yeah, this is what about the versioning. So let's say if you want to go back in time and want v1 to be used again, you can simply use v1, and v2 will be v2 will be the older again. So v3, there will be one more file.txt #v3 will be created, which will be equivalent to v1. And now automatically your whenever you fire any command, v3 will be working as the latest one, which will be exact copy of v1, right? So that way you can go back in time also for using versioning. I hope that point is clear. Then another one is life cycle. This is very important. Life cycle management policy. Okay, so life cycle management policy and retention policy are mutually exclusive. Okay, if you turn this on, you cannot use this. If you turn this on, you cannot use this, right? So retention policy is basically to avoid any modification to your file, whereas life cycle management is to automate the modification. So what you can do is, let's say there is a business need in your project that you want to use this particular GCS file. You want to keep your data for your project only up to 5 years, let's say, right? After 5 years, you don't need that data. Just assume this is a business need. Then you can create a life cycle management policy. Okay, one rule that you can write, that what the file with age more than whatever is the number, right, 5 years, then delete the file. Simple, right? So what will happen is, whenever the file arrives in GCS, that will be the time 0 for that, right? From there it will wait for next 5 years for that file, right? So it will be age of that file, not at the bucket level, but age of that particular file. So whenever that file is 5 years old, automatically the next day it will be deleted. I mean the next time, I mean the next second itself, it will be deleted from that bucket. So that way you don't have to, even you can say to not to delete but archive it, right? Create a zip of it, or send it to some other cloud storage class, right? So now that brings to one more thing is, we have something called as storage classes. Okay, you can even change using the lifecycle management policy. You cannot just delete, but you have other options also. Okay, so that is called as storage classes in cloud storage. So what is the storage class? What are the different storage classes? We have standard, we have nearline, we have code line, and we have archive. Let's just understand these things, and then we'll jump on to the creating buckets, because this will be the questions that will be asked when you create a bucket, right? So let me put this particular differentiation that I have created already. So it's better to directly see the differentiation, and why they have created like this, right? So Google has created 4 storage classes, right? So whenever you create a bucket, right? Bucket, you can just imagine that as a parent or a root folder. Okay, so that's your bucket. It's called as bucket. Under bucket, you can create folders, or you can directly upload files also. Okay, so the bucket is nothing but your root, where, and you can create multiple buckets also, right? So this is one just simple bucket. Now when you create a bucket, it will ask you for the storage class. It will ask you for the storage class, right? You have to choose one of them. Okay, so we'll see what are those and what are the differences of these storage classes and why do we need that. So let's say there was a business need. So let's keep an eye on use case, right? So if you're creating a bucket where you want to store the data, which you want to keep for brief time, a small time, a data intensive computation that you keep on editing every now and then. So that is also called as hot data. Hot data is nothing but the data which is frequently used, which is very frequently being used. You can store the data today and tomorrow, or even today itself you want to use that data for processing. You want to you have some jobs, some shell scripts or some Python or any other jobs that you want to have a processing, right? So for that processing you need data, and you can store the data in a bucket. So that time, in such a way, in such cases, you will always go for storage class called a standard. So what you get with the standard storage class, the minimum storage duration is none. I'll come to this. I'll come to this. So what does this mean is basically, what is the minimum storage duration is, it's not a contract, but it's just the kind of a limit. Not a limit, I would say, but it's kind of a um, uh, what I can say, some recommendation, right? That okay, if you don't want to have any minimum storage duration, you can go for standard. With the standard one, immediately you would be able to access the data, right? There will be no retrieval cost. If you choose the standard one, there'll be no retrieval cost. So when you try to fetch the data, it will be free of cost. Okay, okay, but for storing the data you will be charged for $0.02 per GB per month. Okay, that will be the costing that you will have to pay for storing the data, but for retrieving the data it will be free. Okay, now here comes the near line, where you, then why do we need a near line or cold line, right? So if you see here, near line has 30 days of minimum storage duration, right? So what do you get by this deal, right? When you select a nearline storage class, you get to store the data for half of the rate. So you just, instead of 0.02, you can store the data at 0.01 dollars per GB per month, right? It's a half the rate of the storage for standard compared to standard one, right? But the problem here is, if you choose nearline only if that you have to store the data for 30 days. Otherwise, what does this mean? I mean, it doesn't mean that, let's say you have a bucket which is of type nearline, and I have stored one file.txt on nearline bucket. Okay, it does not mean that I cannot retrieve it back. Okay, it doesn't mean that it is not accessible for next 30 days. It's not like a lock, right? So it's like a soft lock, or you can say just a recommendation kind of recommended lock, right? It's I can say that it's a recommended lock. Recommended lock. Okay, so it's not a lock on your file that for the 30 days you will not be able to access the file. It is not the case. Okay, immediately after the next very second you would be able to access it. But since you have chosen nearline, GCP gives you this discount at the deal, at the trade-off that you do not touch this data for next 30 days. Otherwise, you will be charged for 0.01 per dollars per GB. Okay. So where it is required, if you have a use case where you need monthly reporting, right? So for monthly reporting, it will be just 1 month. After that, you will have to collect all the data and do the processing for that month, right? So it may happen that for the 30 days you will not touch that data, and then only once in a month you need to touch that particular data, right? So that if you have certain jobs like that, then you go for nearline, and for such data your storage cost will be half. This cost is only applicable if you break that particular deal, right? So Google says do not touch the data before 30 days. If you touch the data, or if you fetch the data after 30 days, then this will be free. Okay, this is the only retrieval cost if you do before this timeline, right? This retrieval cost will be applied only if you break this deal, or uh, you know if you try to fetch the data before the minimum storage duration recommended, that is 30 days here, right? Similarly, the code line will be 90 days. So let's say for quarterly analysis, for auditing purposes, or some very infrequent data you want to, once in a quarter kind of retrieval that you want, then you even get it at another cheaper level, right? It's $0.004 per GB per month. But at the trade-off of you need to store that for 90 days. If you retrieve your files before 90 days, you will have to pay for this much per GB. But if you retrieve it after 90 days, it will be again free retrieval. Okay, similarly for archive is like for long duration, like a disaster recovery or online backups or data archiving. You can, let's say you don't want data to be accessed, let's say once a year, or not even once a year, whenever if there is any natural calamity or some disaster happened or something like that, then you always go for the archive storage class, right? It will be way cheaper than rest of the three. But if you try to access that data within that particular year itself, then it will be the highest retrieval cost that you have to pay. After 365 days, that will be free again, right? So is this the storage classes clear? If it's clear, then let's see the that in action on the console. Any questions, guys? And is everyone sleeping? Is a blob storage different? Is it related to cloud? Blob storage. You can consider this as a blob storage only, right? But a blob storage on the generally is basically, you can say, large objects, right? So in typical way, this is very similar to that, but blob storage also being used by the relational database also, right? So yeah, but it is very similar to the blob storage only. It's a large binary objects, right? Why it is free for 30 days? Why it is free for after 30 days? Okay, so good question. Basically your question is why the charges are why it is free after 30 days. Now your question should not be why it is free after 30 days, why it is basically charged less for the retrieval. Why it is charged less for the retrieval? If you are saying after 30 days why it is free, that's what, right? Because you are basically trying to put the data for nearline or cold line or archive for a certificate for a certain duration. That means Google expects that you are not going to access it, right? So Google, by understanding this need that okay, this data can be archived somewhere, okay, it can be stored, it can be, you will still get that data, okay, it's not that you will not be able to fetch the data, right? But Google understands that okay, this is like a like you do fixed deposit in your bank, right? You can break the FD, but it will be penalized, right? It's not that you don't have access to your your money in the fixed deposit. It is still your money, but you are telling the bank that okay, I am not going to access this for, let's say, 6 months, right? So that's why what banks do, they give the use that particular money for, they have the liberty to use that money for lending that to someone else. Similarly, the data that you store for nearline, cold line, and archive, for you're giving some guarantee to GCP that uh, I'm not expecting to use this particular data for these many days. What happens is Google do not so Google can store it in such a way that you don't have to, I mean, and it at the same time it also understands that it's not going to access. That means the some network traffic on that particular data will be less, right? So the data does not move. That's the expectation from GCP side. That's how they save the money on the network cost, right? So it's not going to be used for that particular uh, duration. That is the assumption that you get with when you choose for the uh, that particular storage class, right? That's how Google stores the Google saves the money on the network cost, and then they give the same discount to you on the storage cost. But since you break the law before 30 days only, you have not law, but their terms and condition, let's say, you try to access that within the limit, within that particular minimum duration. That's why they charge you for the retrieval. After that, it's just that they have saved that much, right? So then it is basically retrieval will be free after that. Um, it it is it could be little tricky, but that's how, I mean, I hope I am able to convey what I'm trying to say with all those storage classes. So the longer duration that you have, the possibility of keeping that data for a longer duration, the more you know um, pennies that you can store on your pockets, right? That's how it is. You can just relate that with like a fixed deposit uh, in the bank, right? So let's go and go to cloud storage, and now let's see, let's create one. Okay, so this is how it looks like. You can just click on create. It will ask you for a bucket name. This bucket name has to be globally unique. Okay, this has to be globally unique. So if you want to make it globally unique, just create let's say with some naming convention, maybe like a project ID or some whatever is the uh, use case for this particular, what type of data you are going to put in this particular bucket. You can use that, but do not use any sensitive information, just to make it unique, right? Do not use any sensitive information in your bucket name, right? Just to make this particular bucket, bucket name globally unique. Do not use again any passwords or anything like that, or of course. Okay, so just make it like, let's say, let me create it with uh, our batch was 2708 batch, right? So let me just give this number, so that it, otherwise it will tell you if I cannot use that particular one, it will, what happened, man? So this is, let's say, this is also possible, right? So if I only keep Edureka, this is also possible. Okay, so there is no bucket in the entire world in GCP with the name Edureka, so I can create that one also. But just if I forget to delete this, then I'll not be able to use. So let me just put some number to it, right? Then the next one is the location, right? You want to use multi-regional location, so you have to use multiple automatically. You can't choose the regions, okay? You can choose the multi-region. It will automatically create the replicas of your data into United States, right? You can choose Europe, Asia also. Okay, so let's say go with US. If you go with the dual region, then within that particular continent, let's say in Americas, there is, you can choose these. This will not be supported. This particular dual region is only supported by certain set of regions. Not all the regions in America or US region will be supported. For dual region, we can only see only these four you can support, and you can select two of them, right? So within these two regions, the data will be replicated for you. And you also have a turbo replication, right? So what will happen is, with turbo replication there will be some additional cost, but it will guarantee that within 15 minutes the data will be replicated. So basically it works like one master replica and other read replicas it creates in the backend. So the master replica always reflects your whatever the data you fetch, that will be from your master replica. Okay, and if you want a turbo replication, within 15 minutes it will guarantee that it will be replicated to the other region. If you want more than that, you can go for multi-region also. For us, we can go with regional also. Anything is fine. Okay. Then let's go with this. We can go with anything. Um, doesn't matter for demo purpose. Then this is the storage class that we were talking about, right? So this is best for short-term storage, right? If you want frequently use your data, then go for standard one. If you want once in a month, once in a quarter, once in a year, then go for the respective one. Let's go with the standard one for now. Then you have access control, which is uniform and fine grained. So what is uniform and fine grained is uniform, fine grained. You can provide permissions or access at object level, and this is access at bucket level. So if you keep this bucket as a uniform, then your access is that whatever you provide, that will be applied to all the objects in that bucket. If you have if you want a finer control, you can go with fine grained also, right? Then what is this checkbox is enforce public access prevention. So basically if you keep this on, you cannot make your file as public. Okay, so by default this will be disabled. You cannot make your file public for public use. But if you have any website hosting or something like that, right, then you can always disable that, and then you can create a public URL of this. I'll show you if time permits. Let's keep it fine grained. If I want to change the permission of a particular file, then I should be able to do. Then I can go for uh, fine grained. Then the protection you see here, there are multiple options: retention policy, object versioning, none, right? So retention policy, as I explained you, I can keep this like, let's say 1 day, and I can select days, right? So what will happen is, whatever the file I upload to this particular bucket will have to stay here for at least 1 day. Nobody will be able to delete that file before 1 day. On the next day, we can delete that file because the retention policy has been over for that particular file. Okay, so if you want some accidental deletion of the file, or modification of the file, then you can turn it on for 1 day or whatever time you want. Okay, then under data encryption you have options. It's by default, all the data on the cloud storage will be encrypted, right? So it's not that even anybody else will be getting access to that, right? So it's always encrypted by Google managed key by default, but you can also use your custom managed key also. Okay, So let's create one bucket, and now this is how it looks like. Okay, so you have certain fields over here, certain tabs over here, and this bucket is right now empty. I can upload a folder itself. I can create a folder. I can upload the files, individual files also. Once I click on that particularly, this will ask me for files from my laptop. Okay, this is expecting the files to be uploaded from my laptop. So let's say I upload anything, upload a file with a retention policy. See, so it says that this bucket has a retention policy of 1 day. I say okay. So I have uploaded the file. Okay. Now if I want to delete this file, maybe I should be getting that error because the retention policy, right? Could not be deleted. So I went into this details to see, right? So it has a retention policy and cannot be deleted or overwritten until some timestamp it has printed. Okay, for until that time I cannot delete this particular file, right? So that's how the retention policy works in a simple way. Then I'll show you one more thing is we have another option, right? Retention policy and versioning, right? So for versioning, again versioning and retention policies again, because versioning is to modify it. Is why do we need versioning? Because we expect that our data is going to get modified, and we at the same time we also want an older version of my data to be kept, right? So let me open a cloud shell meanwhile, and we'll also enable the versioning. Okay, so now if you see here, if I want to enable this, it's so it says object versioning and retention policy cannot be on at the same time, right? That's why I have, let's we have a retention policy here, right, which says 1 day retention policy. I can delete this policy now. So I'm just deleting the retention policy. Okay, I just deleted that. Now you see the versioning is enabled. Now I can make it on, right, and add recommended lifecycle management rule for versioning. Okay, so what I can do is I can enable the, let me just, okay, fine. So I can enable the versioning, and what I can do here is I can choose how many versions of my object I want. Okay, as I have explained here, I can, let's say I want to create 3 versions of my file internally, then I can say 3. And whatever the versions, the, let's say I get version 1, version 2, and then version 3. If the 3 is the latest one, that will be by default fetchable directly. It will be fetched the latest, it will fetch only the latest one, right? But what happens to the version 1 and 2 which are sitting idle, right? If in 7 days I know that okay, within 7 days I might require them, after 7 days I don't need, right? So the non current means other than the third one, the other than the latest one, whatever are the other ones, those should expire after 7 days. So after 7 days the version 1 will go off. After 7 days the version 2 will go off, right? Will be deleted automatically. Google will no longer keep it. But until those 7 days, all the internally it will store all these 3 files. However, it will only fetch the latest one by default, but it will also store the total 3 files it will store, and it will charge for all the 3 files. Okay, so when you enable the versioning, you pay more because it might happen that you have internally you might have multiple versions of that file. But when it is very critical, you don't want to lose any data, that's where you can enable for certain buckets. So let's just confirm this. Now it is on, right? So what happens is, let's say there's a command gs util, right? This is the command line tool where you can fire gsutil command. So gsutil is the best command, just like gcloud command. But gsutil is completely for Google Cloud Storage. So I write gsutil. Then what do I want to do? I want to list. So for list, it is ls. And let's hit this, authorize this. So it has given me an output that, okay, these are all the buckets. If I have multiple buckets, it will give me multiple buckets as an output. So now if I want to see what is there inside the bucket, then I do gsutil ls and the bucket. So I got this one. But if you see here, there is no version, right? Because I just fired a simple ls command. If I want to see the versions, there is one option that I can do, a. So if you see here, it has given me some version. It's not a v1, v2 like that. It is some number, right? It might be a timestamp, epoch timestamp. Okay, some Unix representation of the time. It can be a very long number. That version it has been attached to. Okay, but if I do a normal ls, then it will always give me one. So now what I am going to do is I'm going to the bucket, and I'm going to the bucket, and I'm going to upload the same file again. So this time it is asking me whether you want to exclude this, means skip this, or you want to override the file, right? So I'm going to override the file. Okay, so now it has been overwritten, right? You can see the timestamp latest. You also see it says that version history one non-current file. Also non-current file means there is one file, uh, there is a old version of this file also. You can see only one file here, but and the same thing will happen here also. You will still get only one file with normal ls command, but if you do it with -a, it should show me the another version of it. So this was the first version, right? It also showing me now the second version. So this is the latest version of that particular file which is being fetched now. Okay, so that's how you can have multiple versions. Also you can always restore the previous version also, but right now, even though you feel that you have only one file here, you still have two versions of it. That's why you will pay for two files basically. Simple, right? Then the next one is life cycle, right? So life cycle management, as I told you, right? You can add a rule. Let's say add a rule, and now let's say a simple example that I had given for life cycle, right? You want to delete the file which is more than 5 years old, right? So you can do delete the, what do you want to do? You have to select an action. So what do you want to do in action? I want to delete that object, continue, and you have certain options you to choose from, right? Which are created before something and all. Let's say simple one, age. If I say I have to give it in the days, so let's say 365. So after 365 days, that's it. I have created one lifecycle policy. After the 365 days, the moment we upload a file, right? From that point onwards, it is at the object level. Okay. So the moment we uploaded this sample text.txt, this one, right? From here up to 1 year, it will keep here automatically. It will be deleted after 1 year of its age, right? That's the life cycle. You can also add, basically what you can do is, let's say for today you can create a storage class standard, right? You can also make that, okay, after 6 months I don't want to delete it right away. I just want to put it into archive. So my storage class for that particular object will be changed to archive storage class, right? Age, let's say 180 days, right? So around 6 months, after around 180 days, automatically my particular um, object will be considered as an archive storage class, under archive storage class. That means I'm expecting that I'm not going to Google will expect that you are not going to touch your file um, before 1 year. Okay, and what will happen is there is another policy that we already have, life cycle management policy, that after 365 even I don't need that as well, right? So I can just simply delete that. So some different types of versioning that you can do, right? So depending upon your use case, you can always go for different types of tweaks and all these rules you can add. Okay, so any questions until here? Otherwise we'll go to the next one, but yeah, let's break for 5 minutes. Before that, let me check the questions. Which storage class does the GCP free trial by default choose? It's a standard one, not just the free trial. It's nothing to do with free trial, right? The same thing you will do with your paid account also. Whenever you create a bucket, by default it will be standard. If you are creating any storage, it will be standard, but whenever you create a bucket, that time you'll have to specify anyways. By default it will be chosen on the form as standard. um, Retention period will delete the object automatically after 1 day. Okay, that's the exact uh, I mean, okay, retention policy. Okay, let me read this out and clarify for everyone. Retention period will delete. The question is, retention period will delete the object automatically after 1 day. No, it is to protect that nobody should be able to delete before 1 day. Okay, it's the other way around, Nahid. Okay, retention policy, as the name suggests, it wants to retain the file for 1 day at least. Life cycle management policy, on the other side, you can make it make a like this. You can add a rule, delete the object, continue, age, 1 day, right? This is the exact reverse of retention policy. Now what will happen is, let me delete the other ones. Now what will happen is, as soon as after 1 day this file will be deleted. Okay, it will delete the object after 1 day. This is what uh, this particular lifecycle management policy will do. But retention policy is to keep a lock on your file so that nobody should be able to delete it. Okay, CMEK customer managed key, why is the status failed when file was uploaded? Sorry, I did not get you, Dia. Uh, can can I share the file with someone else if I want to share assignment with you and I share the URL of the GCS? Yes, Shrey, you can do that. So basically you can make it public. Either you can give me permission of your bucket to my Gmail ID so that I will be able to access that particular bucket directly, or else you can make it public so that it will be accessible for everyone. So one sec, give me a minute. So what I can do is, let's say if I go to objects, right, this file. So what I can do, so I can edit the access for this particular file, and I can make an entry user. I can select public. Okay, and all this should get reader access, save. Now if you see here the public access, it will create one URL. I just copy this URL and I paste it to everyone. So hopefully if you click on that, it should open up this particular file for you also. Now you got an access. So this is how I made it public. So, okay, would that be possible? Yes, that's what I showed you, Shrey. I hope that is what you're looking for. After lifecycle policy is clear. Okay, thanks, Naid. Nearline can be changed to code line archive, but not the other way around. Similarly, code line can be changed to archive. Yes, code line also can be changed to archive, not the other way around. Correct. What is the CMEK used for? used for while creating the bucket. So basically, if you want this file, this particular all the data of this particular bucket to be encrypted, okay, to be let's say sometimes what happens is for certain companies like banks, right? They do not trust the Google's managed keys, right? They already have the key management system in their projects, and they want to use the same key management keys which are generated on their key management system to be used for data encryption on the cloud side. That's where most of the services you will find that it supports CMEK, that is customer managed encryption key. You will have to manage your encryption key on your external KMS system. You can specify that particular key while creating the bucket. All the data while storing on the Cloud Storage will be encrypted. Encrypted means I don't mean this file will be an encrypted on the storage side. When this file gets stored on the Google Cloud's storage service, means like some rack where that is getting stored, that time it will be encrypted. Nobody will be able to, even they get an access, it will be in encrypted form unless your key itself will be able to decrypt that, right? And since you have to specify what is my key, then that key itself will be used for decryption of that particular data, right? Doesn't mean that this file and its contents are encrypted. The file where when it is stored, it will be encrypted and then it will be stored. Okay, I think we are having we are actually lagging uh, a lot. When you upload a file, creating status of the file faced, what does that mean? When you upload a file first time, when creating a, okay, that will have to see the separately. Let's not see what is happening for you. Is encryption mandatory for? Encryption is not mandatory, but encryption is default. For you it is not mandatory, but by default it will use Google managed keys for encrypting your data. So it is not mandatory, but it is always a good practice. And Google does not ask you to provide the key always. It has its own Google managed keys as well. Okay, that time it showed failed status for the file. No, 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 no. During, no, no, I think you got confused. While creation, let me open test one. It's not allowed. Let me just put in some random number. Region, continue, standard, continue, continue. And okay, we had selected this one. It's fine. Then encryption, I just selected the default one and I said create. It had asked me to enforce the public. That's okay. Anything is fine. I don't see that we got any error. The error that you might have seen earlier was during the retention. For this bucket, we had this retention on. We had this retention policy on, right? Because I disabled it later, right? So when we created this bucket for the first time, this I then tried to delete this file. I tried to delete this file that time. That time I got the error that, and then I moved to that error page also. I showed you that it failed because of the retention policy. It did not fail to create the bucket there. Okay. While creating the bucket, I don't recall that while creating the bucket we got any error. Okay. So now if I delete this on this, so it should be able to delete. Okay, because the retention policy is I made it off, right? When you uploaded the file, the status of the file uploaded file showed failed. Let me do that, and I'm not sure whether this happened. Okay, let me upload one more. Is this what you're talking about? This is not failed. This is just a warning that you have a retention policy. Okay, I'm just confirming. I really don't think so that we got any error other than that retention policy. That is because of the retention policy. I think there we are digressing a lot. Let's hold on. Let's please park this and let's do it after 10 o'clock. Okay, then you can we can talk and we can try it out. Okay, it should failed in red last time. Maybe what you're doing, what you're saying is this one. Let me show you. Is this what you're talking about? That's what I've been telling you. This is because of the retention policy. If you're talking about this one, this is not because of the while creating the bucket. This is while deleting the object which is under retention policy, which is like a lock on that. I think yeah, that's what it is. No, I'm 100% sure they are. Okay. Um. Okay. So okay, let's go further with the next topic that we have. Or shall we go for a break? Please tell me, guys. Shall we continue or shall we go for a break? Okay, break. Okay, fine. I'm going to give you 5 minutes of break, but we may have to extend this today because I'm okay. Let's take a break and then let's see. Let's try to cover everything. But yeah, okay. Then enjoy the break. Let's be back in 5 minutes. Okay, and we'll resume back from there. Thank you. Okay, I'm back. Okay. Okay, so the next one that we will start is the data transfer options that we have. Okay, so now how do we bring the data into GCS or into GCP? Okay, so GCP supports some options. Okay, some built-in options, I would say, to bring the data from other either other on-premise, some other on-premise option or some other clouds also, right? So if you go to the just type data transfer and you will get this particular option, just select this and you will land on this particular page, right? So there are a couple of options over here. Okay, so if you see here, transfer job, right? So now this there are certain options that you have to select. So let's say what is the source, what is the destination, right? So first of all, based on this particular combination, these values or the settings in these values will be different. We are not going to, I'm just making you aware about this particular concept. We are not going to see any live demo or anything on this particular piece, but this is just for your knowledge that we have option to create transfer jobs also, and then you can schedule those also to run, let's say daily and hourly or something like that, right? So you can, with this option, you can either copy data from GCS to GCS also, from S3 to GCS also, from S3 is similar to the GCS in Amazon, in AWS basically. In AWS, it is called as S3. In Azure, it is called as blob storage, right? So you can copy the data from Azure blob storage to GCP cloud storage as well, right? Similarly, you can have URL list. Okay, so it's basically you can you know connect to your on-premise, and you can specify the tab separated values of the URLs of your files on the on-premise side, and those automatically will try to be synced, or you can transfer those many into Google Cloud Storage, right? So depending upon different source and destination combination, these options would be different. So let's say let's go with GCS to GCS for now. And if you see here, it's asking me for a bucket. I just need to give some source bucket name, and instead of doing that, I'll show you from here. So on the destination also, I need to select the bucket. Then under settings further, we have some other options like access controls. So what do you want on the, when the data is copied on the destination, do you want to have any ACLs on that? Basically it's like some access controls or some permissions that you want to do. Okay, what is the storage class of your destination bucket you want to choose? Do you want to preserve from your source side? So let's say the source is nearline, then you want to use the nearline automatically on the target also, or you want to specify of your own, right? So or you want to use the storage class of the destination bucket itself, right? So all these options are there. Then do you want to have a temporary hold on your object, something like that? So all these options are there. And then do you want to preserve the metadata, you don't want to preserve the metadata? All these options are there. Again, some options on overwriting or deleting the, let's say delete the files at the source, right? So once those are migrated into GCP and the target, I would say, not GCP, it can be GCP to GCP also, right? So once it is moved to target side, the source side will delete the files, right? Delete from the destination if not also at the source. So it's basically, let's say on day one you copied file one, on the day two, file one is not present in the source. Let's say it will always compare, right? So if you have selected this one, it will always compare the files between the source and destination, whatever are not there on the source side, Okay, even though those were copied yesterday, it will be deleted from still it will be deleted from target today. Okay, it's basically to sync. Basically, it's like a sync between source and target. You can create this kind of delete policy also, right? Similarly, maybe you can choose S3 and then see next steps. So for S3, it will ask you for access key, access ID, right? These are some you have to generate on the S3 side, right? And at the same time, you also get, I mean, these should be the way you get access to your S3 bucket. And then here you can specify S3 bucket path. Then on the destination side, you can choose the GCP path, GCS, Google Cloud Storage path, and then rest of the settings. Again, there are some settings changed here. Now there are no more ACLs and other options, but you still have option for storage class to select whether to use the destinations or you have to choose. Uh, you cannot choose the source storage class to be used in GCP because it's a different cloud itself, right? Similarly, in blob storage, your things will be little different. You will have some other shared access signature to get the access, right? So depending upon these combinations, you will have to provide that particular information, and once that job is ready, then you can either make it run for every day, every or once. You can start it now, or you can schedule it to run, let's say run on this, and you can also give up to a particular end date. It will run every day at particular time also, right? So you can specify that time also, and some expiry date of that. So all these things you can do with transfer job. Okay, this is one functionality to create a mass, I can say, copy from your source destination to your target destination. Okay, then this is by creating a job. So you don't have any you don't have to write any job, you don't have to write any code for bringing the data. This is the in-house way of bringing the data. But if it is not supported, then you can either have two options. Either you can, if your on premise has a good bandwidth, right, support, and you want to have some VPN connectivity, let's say, right, hybrid connectivity we have seen, right? So if you have established a VPN connection, then you can connect your jobs directly to pull, you can write some jobs. We will see that in big data or something, right? You can write data proc, you can write jobs on data proc, you can write data flow jobs, right? So you can bring the data using your code also into GCP. That is also one other way. Or if that is also not possible, and or let's say your bandwidth is less but your data is too much, let's say more than 30. So let me go here. Okay, so if your data limits or data capacity that you have on your on-premise or your source system is more than 40 TB, okay, is is equal to or more than 40 TB, then you still have an option. And your network bandwidth is not enough. So what will happen if you still keep on writing a code and try to fetch the data from source system and dump into GCS using the code? It will be months and months to bring the data of that size uh, into your target GCP system, right? So that's where you have an option of something called as transfer appliances. So what is transfer appliances? It's like, there's one diagram for this. I'll show you how it looks like. Yeah. So transfer appliances looks like this. Okay, it's like a suitcase, a small suitcase, and it's like a network hard drive. So what happens is Google can ship this particular equipment, right, this particular transfer appliance to your data center, on-premise data center, let's say, and just like any other network device that you have, it can be attached. It also can be plugged as a network drive, and it will start seeing, you will start seeing that on your network, on your data center, on-premise data center, and then you can offload all the all your on-premise data onto this appliance. Okay, and then what will happen is this particular appliance will be shipped back to Google's data center physically. Okay, and then it will be plugged into their network, and the data will be offloaded onto a target GCP, I mean the GCS bucket, right? The cloud storage bucket. So you'll have to, when you apply for the transfer appliance, right? When you place an order for a transfer appliance, that time you also have to specify the target GCS bucket on which this data needs to be offloaded. And then um, this is again a little expensive option, but we have used this in one of the project where it was around 60 TB of data we wanted to bring. Okay, so I think it was a year back. Okay, so there is this option, transfer appliance request. Okay, this is little expensive than the other options, but again, if you don't have that bandwidth, if you don't have to do all that stuff, you can directly dump all the data. The history load, I would say, right? This is generally being used for the history loads where the data size is huge, and you don't want to spend lot of time and energy and resources writing the jobs, right? And you, at the same time, you don't have option for writing the transfer job also. Okay, so in that way you can choose different capacities. Okay, let me enable this. Meanwhile, I think here also I can, yeah. So from this one here, you can still monitor the progress of that particular data to your appliance, to cloud storage. But before that, first of all, the first thing that you need to do is the request for the appliance. Okay, so transfer appliance, and what is the location? So you have to select the location, which area it is, right? So let's say I have my data center in US. I don't see don't have a support for India location. So if your on premise is in India, then you don't have transfer appliance option yet. Okay, so let's select United States. But then for it is not that you can't bring the data into GCP, right? You have other options also. Okay, so recently they have also okay, so if you see here, 40 TB and 300 TB, these are the two options. They were there earlier, but now they have also introduced one compact option of 7 TB also. I don't think for 7 TB, ideally there can be some other things also which can be done. Okay, like simply using some data flow job or something, you can have it bring into GCP. But yes, if for those uh, they want to have a quick one, maybe for that 7 TB of data also it can bring now. Okay, but earlier the options were for more data, right? The 40 GB and 40 TB and 300 TB. So based on your size of your data in your data center, you will have to choose either of them, right? And then let's say you'll have to give some ID to three whatever, and you have to also specify the let's say target cloud storage. Okay, next step, yeah, then here you have to provide your contact information, your company name, your delivery information and all those things, and based on that you have to submit this order. That, and after that it will create that particular order with Google Cloud, and then they will ship uh, that particular physical device to your data center. Okay, and then your network team has to plug that into your data center's network as a network drive, and then you can simply since it's now a native drive that it is attached on directly on your data center, so you can offload the data on your particularly that local network drive. It will work as a network drive, local network drive for your data center, right? So that transfer will be faster. Once the entire history offloading is done, the same transfer appliance will be shipped back to Google data center. okay, and then it will be offloaded in on that particular I would say Google Cloud Storage bucket. And then once it is started, it will be done by the Google Cloud engineers itself. But here you will be able to see the that offloading process, monitoring the progress and all those things. So that's all about the transfer appliance also. This is again just you should know about all these options. Okay. So nothing nothing demo or anything can be done here. Okay, this is like a physical device that will be shipped. Okay, so that's all about the transfer appliance and transfer other options that we have. Okay, so let's jump on to the next topic, that is for the databases. Okay, so now let's say your business need is not for the files. You have data in your, let's say on premise, you have some relational database, right? Let's say you have MySQL, let's say you have Postgres, or any other relational databases, which are generally like a database, and then under that we have tables. In the tables we have rows and columns, right? So I expect that you guys know something about SQL's relational structured databases already. So if you want a similar solution in GCP, okay, a similar solution for your relational database in GCP, then you can go for relational databases in GCP. If your data on the on-premise or for your applications, it is generating some data which is unstructured or semi-structured or non-relational way, then you can go for non-relational databases, right? Depending upon your use case, you will have to either choose relational or non-relational databases, but it is certainly not the object or the file storage. It's not the unstructured files that you are storing. Basically you have semi-structured or non-relational data that you have to store, you want to store. Okay, so like uh, as I said, right, you might be already aware databases, tables, primary keys, views, materialized views, right? All these things which you can do in any relational database, the same thing you can do here also in relational databases of GCP. But what are those relational databases options that we have in GCP? One is called as Cloud SQL and another is called as Cloud Spanner. Okay, so let's focus on Cloud SQL. Now, one obvious question might come to your mind is like, why? So basically, why do we need a SQL solution, right? We may there is one option that you can create a VM. We have seen multiple VMs creation now, right? By now, so we can create a single VM and we can install MySQL on that, right? You can do that. You can create a single VM, simple VM, and then you can install Postgres on that. You can use that. You can certainly use that. But the very important point of using uh, any cloud system or a cloud service is to have management overhead, is to avoid management overhead. That means this keyword that I keep on talking about, managed service. Okay, this is the exact what is say the point that is important to catch here is it is managed. When it comes to Cloud SQL, it is a managed service. What do I mean by managed service? There are these things like patching of the database, things like automatic backup of the database or replication of the database. All these things will be taken care by Google Cloud on your behalf if you choose the managed service of that particular type. Okay, so managed is just a word. Managed service can be for different service, can be managed or unmanaged type. If you create a VM and then you install MySQL or PostgreSQL on top of that. It's not a managed service, because if something breaks on your VM or on your database, then Google will not be responsible. It will be your responsibility because you installed it, right? But on the other hand, if you select Cloud SQL solution, Cloud SQL as your solution, then you can have, you have three flavors here also. So you can create MySQL, you can create PostgreSQL, and you can create SQL Server also. Okay, so you can have Cloud SQL, and when you create a Cloud SQL, it will ask whether what type of database you want. I want MySQL. Okay, it will create an instance of MySQL type, and all those things, like which I told you, right? The backup, replication, patching, everything will be taken care by Google Cloud automatically for you. Okay, so that's the beauty of having or using the managed services. So you will keep on hearing these term managed service. Okay, now onwards, because Google Cloud is it internally, if you see, it also does the same way. Okay, it also creates a VM and it installs the MySQL on top of that, but they have certain other things. The way they want to manage, they actually manage these services, which you will not be able to see, but underlying, all the management will be done by the Google Cloud. Okay, you still will be able to you can access the Cloud SQL using the same tools that you use for let's say on-premise database. So let's say somebody might have worked on Toad, somebody might have worked on SQL Workbench, right? There are a lot of them. um, I had used what was that, DBeaver or something, right? So any database management tool or querying tool, right, that you can use on premises, all those things can be simply and exactly same way you can connect to your Cloud SQL also. Okay. Um, then some of the features of cloud storage. Let's talk about some features. Okay, so you can choose different storage size. Okay, maximum up to 64 terabytes, I think. We'll see on the console. We'll confirm there. Maximum up to 64 terabytes of data that you can store on this relational data. Basically, you can store. This is way big, uh, capacity for from the relational perspective. If you see, right, depending upon the size, your IO ops, the input output operations that you will get will be different, basically directly proportional, I can say. Okay, so basically the higher the size you select, you will get more input output operations supported for that particular type. You can choose machine type also, different types of machine types also you can select. Okay, maximum you can select is up to 96 virtual CPUs. Okay. These are some of the infra level settings that you do when you create a Cloud SQL instance. Okay, now this is not good for horizontal scaling. Scaling is not supported. What do I mean by that is, the maximum size you can choose is directly by selecting that particular. You have to select an SSD or an HDD, just the way you create a VM, right? I told you, right? Google Cloud also creates a VM in the backend. Okay, and then it installs this particular MySQL bundle on that. You don't see that particular VM in a VM page, but it's the same way that it works. Similarly, for a VM, when we created a VM, we attached 10 GB of SSD, you remember, right? Similarly, here also you have option to select how much size I want. Okay, but once you select that option, you cannot keep on adding new nodes or something. Like horizontal scaling is not possible. You can have vertical scaling. Okay, vertical scaling is possible and also can be automated. So what we can do is, what I mean by vertical scaling can be automated means, let's say for today you have let's say selected 10 TB of 10 TB of your size, right? So what you can do is, there is an option for automatic upgradation. So what will happen, as soon as the storage capacity reaches near the maximum capacity that you had selected, let's say 10 GB 10 TB, automatically it will increase to the next value, right? So you can do that as well. You can automate that as well, but the vertical scaling is possible at the maximum limit. Okay, of course, whatever the max limit is, what we are talking about is 64 TB, right? So you can go up to that particular limit only, and horizontal scaling is not possible, right? So it has certain limit to it. Okay, then as this is a relational database, ACID properties will be supported. Okay, so atomicity, consistency, integrity, durability, all these things um, are supported, right? Because it's a relational database, it has to support all these things, right? Again, data will be encrypted, will be stored in encrypted form. Okay, and what else? You can also have high availability. So that is one more thing which you generally won't be able to do if you do it by your own, right? If you're not using this managed service, right, then you cannot use high available server. You have to configure all those things by your own also. So what happens in high availability is, you can choose multi-regional cloud SQL instance. So what will happen is, it will create and it will replicate, it will take the backup of your data into another region also. Okay, so let's say some natural calamity happened, some tsunami or something, and some one of the data center is gone. So that particular multi-regional uh, uh, high availability will help you, because it will be copied to some other region also, right? So that way it is possible um, to uh, get the access. High availability is that point. Multi-zonal is nothing but the same, I mean regional, all right. uh, okay. Oh, I am sorry, there is one mistake. It should be multi-zonal. Okay, so you can create in a different zone within the same region. Okay, then what is the, I mean, where I have used it, the use case can be different. Okay, so generally whatever I have seen, when we migrate the our customers into Google Cloud, basically there are different other data warehouses also, solutions also, where we can migrate their relational databases into now GCP data warehouse. Let's say you can migrate MySQL Oracle data warehouse into BigQuery. BigQuery is a Google's data warehouse. So you can do that as well. But certain projects where you still want the companies or the clients still want to use relational database on the GCP side also, that is where you can use uh, relational database solution on the GCP. Okay, we want to stick our client want to stick to relational database on GCP side, then you can go for Cloud SQL kind of solutions. Uh, Other than that, we have used this for auditing purposes. So what we have done in auditing purposes in one of my project was the jobs that we had written in Dataproc, right? In Hadoop, we had written Spark jobs. In BigQuery, we had created stored procedures, and we had created uh, some jobs. And for all those auditing purpose, okay, so this job has started at this particular timestamp. This job has completed at this particular timestamp. this job has processed these many bytes in this much time, right? All these auditing information about my what I can say jobs or my workflows that we have managed in Cloud SQL. We just created a simple Cloud SQL instance, and we used to keep all those auditing activities or auditing entries in that particular audit table. And for auditing, we use Cloud SQL. Whereas for the actual data, we used BigQuery. In one of the other project, client also wanted to stick to the relational database. That's where we'll have to stick to relational database in GCP. So your actual user data will also can be offloaded onto the cloud Cloud SQL. Okay. So these are some of the use case where you can go for uh, you know um, Cloud SQL. So let's see Cloud SQL. Okay. So go for SQL, and you see you will land on this particular page where you can just click on create instance. Once you click on create instance, it will ask you to choose one of these. These are the three supported ones: MySQL, Postgres, and SQL Server. Okay. MySQL is a Oracle product. SQL Server is, as you know, it's a Microsoft product. Postgres is a open source database, right? So in MySQL, let's choose MySQL. Within MySQL also, it supports multiple versions of MySQL. If you see here, you can go from 5.6, 5.7 as well. I'm going to select 5.7. I just need to give some ID over here. Okay. So I can say Edureka Cloud SQL. Say, okay. Then I can provide some password also. So this password we can use later. Then what type of work that you are expecting here? I am not creating this for any production work. I am just doing this for development purpose. So the configuration details. So according to that, automatically the development, according to the development, it has taken lesser, configurations automatically. And then, as I said, right, you can choose a region particularly, let's say central one, and within the that region you can select multiple zones. So multiple zones will create replica of your data onto another zone in the same region. Okay. So you can even specify that, you can specify that as any, or you can choose that. Okay. So that's fine. Then we'll see the other customizations which are possible. Okay. Here machine type, right? So machine type can be high memory, lightweight, shared, standard. If I go with lightweight, I can go for a single virtual CPU with 3.7 GB of RAM. Okay, this is nothing but the way I told you, right? It's going to create a single simple VM. However, I will not be able to see that, but it is in a way internally it will create some small VM, and on top of that it is going to uh, again to that particular VM it is also asking me SSD size and HDD size also, right? So let's take simple size, and depending upon what you choose, you might see here the IO ops are getting changed, right? That's what I told you, right? When you go higher and higher in the values, the input output operations that are supported will be different. If you go to SSD, it will be way higher, right? Because SSDs are fast. So for now, that's okay. I'm going to with very small capacity. Uh, so HDD of 10 GB. Then I can choose automatic storage increase also. So this is what I was talking about, the vertical scaling. Automatically, whenever you reach the near capacity, okay, the storage will increment, okay, and it will be permanent. You cannot go, from higher capacity to lower, but you can go from lower capacity to higher. If you keep this on, it will be automatically vertically scaled. Okay. Then encryption options, again the same options. You can choose Google's encryption key to encrypt the data, okay, which is default, will take place. If you don't trust them and you want to have your own keys, you can go for encryption keys also. Connection, I'm okay. Just public IP it will create. Data protection, okay. You can create automated backups also, right? And this is one more option, enable delete protection. So unless and until you, if you have this enabled, you will not be able to delete this instance. Okay, this is going to create an instance. Instance is nothing but a machine, right? So this is not going to let you delete it. Okay, so for demo it's okay, but for in production you should enable this. Okay. What else do we need? Maintenance. Okay, maintenance is you can, provide your options when the maintenance should take place. Okay, and that's it. I think rest of the things, flags, labels are fine. So let's try to create a Cloud SQL instance. It might take a while. Meanwhile, let me go to users and let me create one, but I think I need to wait for instance to come up. Okay, so that's fine. So now you can, once it is created, you will get a IP address of some details of your instance, some IP address using which you can connect. We'll try to connect from here. So let me reopen my Cloud Shell. And what we will do is we will connect from the Cloud Shell console. Okay. So I need to set the project ID. Project ID is right here. Okay. Try test. Okay. So my Cloud Shell is ready for connection, but my Cloud SQL instance is not yet provisioned. Okay. It's still being updated. Fine. So we can wait for that. Meanwhile, if any questions, just let me know. Going forward, like, from once this is configured and we connect to this particular instance, rest of the things will be just like SQL queries. So we'll not be spending much time. I'll just fire some queries on the Cloud SQL just the way that you generally fire any SQL commands. Okay. But yeah, meanwhile, I can take up the questions. If any questions, please post it now. What metadata is managed and where it is managed? What metadata is managed and where it is managed? No, it's not about metadata, Dia. It's not about the metadata that is managed. The service is called as managed service. And when we say managed service means the responsibility. I told you, right? The different service models, right? The responsibility lies with whom? Whether the responsibility lies with uh, cloud provider or the vendor like us, right? So if you have a company, what is your tech? Whether you want to manage everything, you want to manage the replication, you want to manage the backup, right? If something bad happens, something gets corrupted, do you have a backup of your data? Do you want to take that responsibility with you? Then you go for a simple VM and install MySQL on that. If something gets corrupted, it's your responsibility. Against, we have another option, which is managed service. So what they do is, what Google Cloud does is, Google Cloud also does the same thing, but they provide that as a managed service to you. So all the database backups, they have all this system in place where when to take backup, what to take backup, right? Where to store the backup, all these options they already ask you when creating the Cloud SQL, and then basically uh, it will take the backup of eventually it will take backups, it will take other patching and all those things will be taken care. So that when these responsibility are with the Google any cloud provider, then it is called as managed service. Okay, so every file, one second, there are some other questions also I'll have to take first. Does GCP have any interface to connect to Cloud SQL? No, GCP does not have any interface to connect Cloud SQL. But what you can do is in BigQuery, you can there is an option for called as federated queries where you can import, not import, you can connect BigQuery with your Cloud SQL, and you can fire the queries on your Cloud SQL. So, but it does not have any dedicated interface. But as I told you, right, even let's say when you have a MySQL, uh, you have to install some client, right? So you install a client and then you connect, you have that connection string and everything, you just configure that, and then you use that particular user interface to connect to your MySQL instance. Similarly, here also it will be some external tool, you can simply use this exact same way. But there is no dedicated one, Abhishek. Can we use KSQL? What is KSQL, Shubhadarshini? Can you please be a little more specific on that? If it is a tool, yes, it should be supported. It's basically the same way. You need IP and username and password, right? So you can use any other tool as well. If you that can connect to your normal MySQL, then it should be able to connect Cloud SQL also. Similar to Toad. Yeah, Toad is not in, it's a external tool, Abhishek, right? So your question was GCP interface. So if there are any other user interface or softwares that you are using, the same softwares you can use here to connect to Cloud SQL also. Every file also has a metadata, uploaded date, who uploaded it, and maybe more. We are not talking about the file. We are talking about relational database. Yeah. If I not able to understand your question, maybe you can elaborate it or you can park it. We can have discussion at the last also if that is fine with you. But we are talking about the relational databases, right? So we don't have any file or metadata in this particular case. Let me refresh. Okay. Then can we use KSQL over Cloud SQL? I'm not sure, Subhadarshini, if I understood your question. What is KSQL? Can you be? I have never heard about KSQL. Shri, Cloud SQL and BigQuery both use SQL. BigQuery is a data warehouse solution, but how are they different? Okay, we'll come to that later. So we have not yet covered. Otherwise, everyone will get digressed to BigQuery. Okay, Cloud SQL is a relational database. BigQuery is a relational data warehouse. Okay, that's the difference. You need to understand the difference between database and data warehouse. That's the exact same difference that you have between Cloud SQL and BigQuery. Okay, but we'll see that later. Uh, in terms of storage of the data, retrieval. Yeah, yeah. Please park it for later, Shay. We'll see that later. I don't want to digress. If so, KSQL, if it, Subhadarshini, are you saying that KSQL is a relational database just like MySQL or PostgreSQL? If it is, then it is not supported. It only has support for three of the database types: MySQL, Postgres, and SQL Server. If other than that, let's say Oracle is also not supported yet, right? So if you want to have Oracle, or if in case KSQL is such a database, then you will have an option for going to create a VM and install that KSQL on that as a separate database. That's the only option. We don't have any managed option for that in this case. In that case, Shubhadarshini. Okay, there we'll discuss at the last. Um, can we get threshold limit of storage? Post that value, only my storage will get increased vertically. No, I didn't find that option. Basically, it automatically detects that particular value. You cannot uh, give that particular threshold value. But if you have certain things, let's say after 10 TB, I want this to be increase, then you set it to, let's say, whatever the nearest 16 TB, let's say. Go for 16 TB, right? Automatically, when it will reach to 10 TB, 14 TB, automatically it will vertically scale. But I didn't find any option to specify what value you want. Okay. Yeah. So now, if I open this particular instance, now you see here there is an IP address, right? But I need a user. By default, it will create a root user, but let me just simply, I'll tell you how to create a user also. I'm going to create a user and I'm going to specify a simple password. Okay, and I'm letting it to connect from anywhere, adding a user. Okay, so it has created a user. So let's go to overview. Let's take the sorry. Either you can use this instance IP, or you can use the instance name also. Let's try. So gcloud is the command, and then SQL connect is the command to connect to the Cloud SQL instance. Then this is the name of my instance, and -u is to specify user. Okay, and what was my user? Cloud SQL user. So now what it will do is, okay, it is just asking me for enabling the API for SQL. Okay. So now it is taking the IP address of my machine and it is just putting that to allow list. This is one time activity. Um, so it's basically trying to understand who is trying to connect, and once that is done, it should basically ask for the password. Okay, so it is asking me for the password. Let me put the password for that user just now, which we had created. And now if you see here, we got a MySQL prompt, right? Now here onwards, I can fire all those commands which I generally we can fire on any MySQL, right? It has some built-in databases also. You can create database, let's say IMDb, and then show databases. It should have one IMDb database created, use IMDb, right? This is it's the same exact way that you work in any MySQL instance. The same way you can fire the command. I'm just taking a command from my notes. I'm just creating a table called as movies. So if I say show tables, I should be able to see that one. Describe movies, let's say, right? So I can see the field names, their data types and all. Let's try to insert one entry. So if you see here, now I can fire select star from movies. Okay, I can see one entry. I can write queries also. Let's not waste a lot of time on this. This is just just the same way that you have, right? I'm just changing the genre of this particular where title is Joker, let's say, right? So yeah, updated. Let me fire the query again. Now it has been changed, right? So that's how basically you can work. You can drop table movies. That's it. It's gone. Select query. Does table does not exist, right? So it's the same things that you go and do from here onwards, the same way. Also, you can programmatically also connect using this particular IP and this connection name also you can connect. Okay. So if you want, you can try it out, right? But yeah, I mean, this is all about the Cloud SQL. It's just that it's a managed service by Google for whatever supported. It supports MySQL, it supports SQL Server, and it supports Postgres for now, right? These three. Other than that, you have to create a VM. So for other than that, you also have an option. One more thing is for others, like let's say Oracle, right? So you have two options. What you can do is create a VM and install Oracle on it, right? That is one option. Otherwise, go to marketplace and find third party tool for Oracle. So what do I mean by that is Google Cloud also has a tie-up with other third-party vendors also. And even though the Google does not support Oracle, it might happen that some other third party might have done this particular tool for you guys. So you can even go to marketplace and opt for that particular third party Oracle tool, and that will be managed by the third party for you, for by that third party company for you. Okay, so that is also possible. But if that is also not available, then final option you are left with is to create your own VM and manage it on your database on that particular one. Okay, I think we are lagging a lot basically. So we'll cover Spanner in 10 minutes and then we'll break for some time. So what is Cloud Spanner? How it is different? So if your performance with the Cloud SQL is not enough, let's say maybe the database is growing very huge, you do not have you cannot go beyond that particular capacity, that is max limits on the Cloud SQL, right? So if you want horizontal scaling, let's say, right, if you want a horizontal scaling of your database, so as soon as let's say my data is growing and growing in the future also, I'm expecting my data will grow to petabytes, right? Not just the GBs or TBs, but to petabytes also. Then and still you want to stick to relational database. Okay, then that is where exactly that you are looking for Cloud Spanner kind of solution. Okay, Cloud Spanner is a managed it's again a managed service. It will keep on adding nodes. Okay, so if I show you on the directly show you on here, I open Spanner, just type Spanner here, it will give you Spanner. Just open the Spanner, and okay, so I can create a, you can create a free trial also. This is one more thing newly launched. Okay, last time I had not seen this. uh, so what it does is, with your free trial account, it basically depends upon if your if your account is a free trial, it they suggest you to use this one, right? Otherwise you can also create this one based on your needs. So free trial Cloud Spanner will not ask you much of your configurations. Okay, it will create just for your learning purpose. Whereas the other one which we selected, here you have a lot of configurations to select. Okay, so not much, but basically you can say Cloud Spanner. Then it will take the instance ID automatically. Okay, then you can go for regional and multi-regional also. So in Cloud SQL it was only regional, you can only go to multi-zone within the region, whereas here you can have support of different multi-regions also. Okay, if you go for multi-regions, you can but again, let's say you selected this particular combination, you cannot select any regions of your own. They have made some combinations, so like here Netherlands, Frankfurt and Zurich. Okay, so what will happen is the best part of Cloud Spanner is you have multi-region support, and that's why you get high availability, a better high availability, I would say, compared to Cloud SQL. Cloud SQL can give you multi-zonal high availability. Here you will get multi-regional high availability. Okay, scaling to petabytes, right? Then strong consistency. Okay, strong consistency, as it is all those acid properties also will be supported, right? All these things will be taken care when you go for the Cloud Spanner. This is little expensive than Cloud SQL solution, of course, but you have something like this. So let's say you go for multi-regional, then what will happen is the first one, that is called as the major, it is called as the main region, leader region, right? So that region will keep two read write replicas of the data. The second region will also have two read write replicas. This is actual replica of your data. Whereas the third one will be like a witness replica. This will not have any, no, this will be in the backend. You don't see these many replicas of your data, but internally how it stores is in this particular format, right? So that will also have some compute cost, which is, see, if you see it, $3 per hour is very expensive, right? And storage cost is different, compute cost is different. And for compute, if you see here, there were earlier, there was only option for nodes, so you can add let's say 5 nodes, so it will be like a cluster of 5 machines in the backend, and it will create Cloud Spanner on top of that. But now we have further classification called as processing units. So you can have nodes or processing units. One node is basically 1000 processing units. Okay, so one node is nothing but 1000 processing units. By default you have 1000 here, that means it is one node. Okay, but now what they have done is Google Cloud has option of, why they introduced processing unit is basically you should be able to go under one node capacity also, right? So one node is 1000, right? So you can go with 100 also, minimum 100 you have to go. So basically 100 is PU, processing units is nothing but 1/10 of the node, right? If you see the calculation, it is 1/10 of the compute power that you can select. So that means your maximum storage will be uh, 410 GB, right? If you make it to 1000, it will be 4 TB. Earlier, as I said, right, the only option that was there is one minimum one node you have to select. That's why the the costing was more. Now, if you're let's say you are playing around for POCs and all, so you can go with 100 also. You can go with 200. It should be multiple of 100. So accordingly, this will be doubled, right? And then you can go with 800, let's say, and then after that 900 is also possible, and after that you will directly go for the first node, right? Then 1000 onwards you cannot go for 1100, 1200, right? You can't go that way. You just have to increase the nodes like this. Okay, so yeah, that's it about Cloud Spanner also. uh, the advantage that you get is horizontal scaling. Okay, horizontal scaling, and with that horizontal scaling you can scale the data all the way up to petabytes of data also you can store in relational way. Okay, this is again a relational database solution. Okay, this is Google's own database. Okay, it is not a a customized solution of an existing like MySQL or anything like that. Okay. So any questions on Spanner? One node equals to 1000 processing units. Yes, that's what I have written here. Correct. So we can go for 100 also, just for a sample, which is 1/10 of the power. Okay. If I want to access DB created in SQL using MySQL and ETL tool, where can I see the DB connection parameters? It depends on your ETL tool, Shrey. If you're using, let's say, Informatica and you want to use let's say example, and you want to connect the same way, wherever I'm not Informatica developer, so it depends upon your tool. Wherever you configure any create new connections in that tool, the same place you can select MySQL and give IP address of your Cloud SQL. You have to create a user ID password earlier. Apart from that, we might need some DB parameters. Yeah, that's what I showed you. I think I'm not sure whether you paid attention on that, but basically on the Cloud SQL, if you go, it gives you that connection string. It gives you your IP. You have your IP also, your connection string also. You also have a username and password also. I don't think anything else is required. All the that's all you need to do, and it should get connected. Okay. Any other questions on Spanner? Else we'll break for 5 minutes and we'll resume at 9:30. We have a lot of things to cover. We have Bigtable, we have Firestore, we have Memory Store, we have File Store. Okay, these are the four things. Out of them, I'm going to cover hands-on on two of them as well. So let's see how it goes. Spanner supports all the ACID properties tray because it's a relational database, strong consistency. All these things will be supported. Okay. Okay. I'll also take a break for 5 minutes. Will be resuming back at 9:30 sharp. Okay. Okay. See you guys. Okay. Okay, so I think we can get started now. So now here it ends about the relational database. So now we are talking about we were talking about uh, relational databases. We were talking about the structured data, right? We were storing the data into something called as tables. We were creating databases, views, tables, all those things we can do with your relational databases. Okay, but what if I have something unstructured data or non-structured data for in my application? Okay, so something like I have JSONs, something I have something like XMLs, right? So if I have certain unstructured data, or sometimes I do have a schema, but that schema is not always the prominent. So it basically keeps on changing. So let's say um, I need a let's say my web application generates one form, and users are filling that form, and I am sometimes I'm getting first name, sometimes I'm but I'm not getting the last name, right? So last name is empty, or their date of birth is empty. All these there are a lot of things, and which are some of the things are optional, right? So some people feel that, some people do not feel that, right? So my schema also uh, keeps on changing. Let's say some people can also provide some more key value pairs, right? Some additional key value pairs which is not part of my database or my table, right? So my schema adoption is required, right? So my schema is not tied up, right? So if we have certain conditions like this, or certain use cases like this, business requirements like this, then we have something called as we have something called as NoSQL database, that is non-relational database, I would say, right? So in non-relational database we have options like Bigtable, and we have option called as Firestore. Okay, so these are the two main options that we have under NoSQL databases. Now let's first see the Bigtable. Bigtable is basically, I would say, the very old NoSQL database, not the very old NoSQL database, but it is basically based on Bigtable research paper. So it has a very good history behind that. It is the same tool that is being used by Google search engine. Okay, then Gmail and Google Maps. All these Google products uses the Bigtable under the hood. Okay, it has, as I said, it has a very good history to it. It's basically when Google search engine came in picture, right? I mean, came in live. So people started using Google search engine. They started searching for different keywords, as we do, right? So what had happened is, after certain years, Google started noticing that there is a slowness in the Google, in this web search. Why? Because uh, at that time the Google search engine used to build the indexes, okay, in the backend, and it was taking a lot of time to rebuild those indexes every now and then. That's where they wanted some solution, okay, where they can get a faster response for the key value kind of pairs, right? And they came up with something called as they came up with some white paper on big table technology. Okay, so this technology was later adopted by NoSQL communities, and after that there were a lot of NoSQL database which got developed, like HBase, Cassandra, MongoDB. You see, right? All these NoSQL databases were based on that research paper which Google had provided for with the name called as Bigtable. Okay, even that those research paper I think got some awards also. What was that? Hall of Fame awards for the decade. the best papers, influencing papers of the decade. That was the award that this big table research paper had got. And later big table was then by Google, they also opened it for as a service for their GCP users also back in 2015, I think, right? So then finally in 2015 they made it available for GCP as service. But until then, they will using internally for Google search engine and Gmail and all, right? So what are the features that we get with this particular NoSQL database is it can scalable to petabytes. Okay, it it is scalable to petabyte. It is eventually consistent. So it's not strongly consistent because it is not a relational database. It's a NoSQL database. It has eventual consistency. Okay, so whatever the nodes that it creates under the hood, they will be eventually consistent with each other. Okay, it's again fully managed service. So all the patching, everything will be done, taken care by Google. Then it can handle millions of requests per second. Okay, it can handle millions of requests per second while fetching the data. So fetching the data. So we can say low latency reads and writes. So if your need is to have a solution in NoSQL database which has low latency reads and write operations you can do, you should be able to do, then you can go for big tables. Also, it is meant for suitable for what I can say analytics analytical jobs. So if you have any analytical jobs like big data analytics kind of job, Dataproc or Hadoop kind of job or Spark jobs, right? If you want to integrate such big data analytics jobs with a NoSQL database, then big table can be a best suitable solution for your need. Okay, what are the use cases? Is basically good for tech and fintech kind of solutions. Okay, where we can have digital media and IoT applications, IoT kind of data, IoT data we can say. All this type of data is getting generated, then again big table is a good solution for that. And as I said, it is based on key value pair. Okay, and it's again columnar database. One more thing, it was columnar database. So I think you might have been knowing already about columnar database. Basically, it stores the it doesn't store the data in a row format. It stores the data for the column. So basically, once you have, let's say, one table you have, and address field is a string field, right? So for all the rows in that particular table, all that addresses will be like a string field, right? So since the columnar, the how the columnar databases generally typically work, they will club the data for entire column, and then they will store that a column based on that column particularly. Okay, so the same way big table also works. Okay, it it's a okay, one sec, it has something called as column keys and row keys. Okay, column keys and row keys in basically, and the column keys are grouped together as column family. Okay, so if you have any edge based kind of a knowledge, okay, then this might be similar to that. Okay, because edge base and big table are very close to each other. Okay, edge base has some APIs. You can use the edge base APIs to access big table also programmatically. Okay, so for programmatic access, edge base APIs are being used. Okay, And then you have support for data science and machine learning use cases also. So machine learning and data science kind of use cases also can make use of Bigtable. Okay. So basically it is for the big data, and all these data science, machine learning, they need a lot of data to train the models, right? So that's where Bigtable is one of the good solution for such use cases also. Okay. So let me show you how it looks like. So here, if I show you Bigtable, go to Bigtable. Okay. Now here you can create an instance. My Bigtable instance. Okay, continue. So here also you can select what type of uh, storage you want. Let's go with SSD. Fine. Then cluster ID, it will generate automatically. Let it be like that, and you can choose which region in which you want to deploy this, right? So I can go for, let's say, our favorite one will go central one. Any zone, it will deploy in any zone, but you can even select. Okay, so that's fine. Then manual allocation. So basically here, how many nodes of cluster that you want? So basically, do you want auto scaling to happen on your Bigtable instance? So you can specify just like your load balancer or MIG, right? Depending upon the CPU utilization percentage, you can keep on adding new nodes to your Bigtable cluster, or you can have manual allocation and just you can specify. For our use case, will for our demo, we'll go with one node, a manual one, and that's it. Let's see what are other options. We can even add another cluster to have even what I can say, you can add another cluster in another region, and then you can use that as a Bigtable instance as well, right? So you can have multiple clusters attached to each other. For now, we'll just create a Bigtable instance, and then here on this one, I'm just going to exit. Okay, and clear the screen. So now I'll show you how we can connect, or how we can use the Bigtable queries. So it's not exactly like SQLs, because it's not a relational database, but there are some libraries which I showed you when we installed Cloud SDK. I showed you like GSUtil, I showed you G-Cloud, right? So there is one more bundle which comes along with the Cloud SDK, that is CBT, that is Cloud Bigtable uh, command line tool, right? One second, guys. Okay, so I have this particular instance ready here, right? So let's try to connect that. Let me take the instance ID, and then first of all, let me uh, there's one file CBT. Let me check that whether it is there. We need one configuration file. Okay, so I'm just checking whether it is there, otherwise we'll create CBT-RC. Okay, it's not there. So what I can do is I can create this value. Now if I see this file, cat, it has one parameter called as project equals to my project value. Okay, similarly I want one more value, is my instance name. So let me fire that command also, but here, what is my instance name? Is it the same? My Bigtable instance. My Bigtable instance. Okay. Now if I see my cbtrc file, let me just cross check. Okay, perfect. So I have project and instance, two variables in my RC file, CBT RC file. This is needed to connect from CBT command. Okay. So now if I can start simply firing CBT command, CBT ls. This will use that CBT RC file now. I don't have any tables or databases created yet, right? So CBT ls is not giving me anything, right? So let me create a table. Let's say my table. Okay. If I do the CBT ls now, ignore this one. Okay. This is just a warning. So now it is saying my table has been created. Since it's not relational, right? So you don't have to specify any schema like you do in relational, right? So you can at different row keys will have different schemas, right? So it's just that it, in non-SQL database, you don't have to have a perfect schema all the time, right? So it's basically depending upon the column key and column family that I showed you, right, on the theory. The same thing you can do here. You can again create uh, family. You need a column family under this table, and I'm just giving a name, column family 1. Okay, so this should create one column family in my table. So now if I see CBT ls and try to see how how the structure looks for my table, my table has one column family, that is CF1. Now under this column family, I can create columns also. Okay, I can create any number of columns. I can insert the data in. How do I insert the data? The command is cbt set. You can even see the documentation of this. So what I can say, cloud big table cbt documentation. If I search on Google like this, let's go here. Creating a cbt rc file using cbt tool, cbt reference. Yeah, here also you can see it here. Cat this file, add these two variables. All these things are already mentioned here itself, right? And then you can explore this tool. Let me see if we can get creating cluster, creating table, right? So for creating table, CBT, create table, and then your table name, right? Delete instance, that's okay. But I mean the column family, create column family. How do you create column family? All these things are already over here also, so you can explore it later also. Okay. So what I have done is CBT ls. Okay, so I am just describing my table. So I have one column family. Let's say I want to insert something. So the command would be CBT set. Okay, where do I want to set the data? I want to insert into my table. Okay, that will go with one row number, not row number. It is called as row key. Okay, and then I need to specify the columns. So I want to specify column called as C1. Okay, or I could say column 1. This can be something like name or comment, right? I can say comment also. Comment is my column which belongs to column family CF1. Okay, and I want to put value like GCP course, let's say anything, right? Comment can be. This is how you will insert the data. Now let's see CBT count on my table. So how many records do we have? We have one. Okay. Then how do you say CBT read my table. If you want to see the records in my table, you can say cbt read, and this is how it will look like. Okay, if you uh, change something in this will create another version for the same row, key. Okay, so this will look like at this particular time this has another comment, right? So you can have multiple versions of the same column also. Then cbt count we have already seen, right? ls also. So delete table, my table. This is how you can drop the table. Okay, so you can explore more. And now if I do cbt ls, I should not be able to see anything, right? So that table is also dropped. So something like that you can do. You can try out the things. If I want to check the details of my bigtable instance, gcloud bigtable instances, it should be instances list. So what it will give, it will give me the details of my bigtable instance. I can even delete the instance, and I can just give the name of name, not display name, but the name of my instance. You want to delete? Yes. So let's refresh. So that's how you play around with bigtable. Then we do have another solution which is called as Firestore. Okay. Now, so far we have seen managed service. This is also a managed service, right? But this is also a serverless. What do you mean by serverless? Okay. So Bigtable is a for Bigtable we created an instance, right? We just deleted that. But in Firestore, Firestore is a database which is a serverless database. What do you mean by serverless? Serverless is again uh, Firestore is one of the service which is serverless. BigQuery is also serverless, for an example. Dataflow is also serverless. What do you mean by serverless is you do not have to even create any instance. You do not have to even create any nodes or cluster or any instance that you can see on the console. It's just that there is a database, you just start using it. Okay, and you just fire the Firestore APIs to access the data, right? Behind the scene you don't have to even manage any cluster or anything like that as well. Okay, so that is called as serverless. So Firestore is another NoSQL database that you get, which is a serverless database. It's again a managed database. Okay, so where it is basically being used, what is the use case is basically for mobile applications, gaming applications. Okay, generally these are the use cases where Firestore is prominently being used. Okay, with Bigtable you get eventual consistency, right? With Bigtable you get eventual consistency. Here you will get strong consistency. Okay, so this was previously known as, I can say previously known as data store. Okay, you might have heard about, you might have not heard about Firestore, but you might have heard about data store in GCP. So GCP data store was the earlier name for the Firestore. They have improvised this particular NoSQL database and they renamed that to Firestore. Okay, now Firestore has two modes. Okay, so those two modes is a native Firestore mode and a data store mode. Okay, so basically you can run Firestore in two modes. One is called as actual Firestore native mode, or other one is the old one is still supported, that is called as data store mode. So let's say you have any gaming web application where you had created a data store earlier, right? And you still want to stick to that solution itself, then you can use Firestore service now in a data store mode. So when you use it, it will ask you to select one of these
so that time you can go for the old version or the old mode also. Okay, so this is basically being used for gaming applications or your mobile applications or your web applications, or a web application means gaming web applications. Okay, majorly for that kind of data, like where you want to maintain, maybe like maintaining, I can say, maintaining the state of game, different checkpoints, let's say some strategy games where you want to keep the track of checkpoints, their scores, right, etc. That's where any user statistics, right, all these things can be managed uh, using the Firestore. Okay, this is again one more thing is, this is very similar to MongoDB. If you have a background of MongoDB, then it is similar to that. It is a document oriented NoSQL DB. Okay, so it's a document oriented. So the data is stored as a document. So it's like a JSON. It is stored as a JSON in case of MongoDB, right? Similarly, here in Firestore also it is stored as a document in the database. Okay, then you get high availability, full managed. We have already covered. It is managed. It is non-structured, of course. It is serverless also, and it supports ACID transactions also. Okay, so if you want to have a support for ACID properties being a NoSQL database, then Firestore is one of the solution for, I mean, it is the solution for you, right? You want a strong consistency, right? Then Firestore can give you strong consistency. If you want eventual consistency is okay for you, then you can go with the big table. For big table, it is good for your big data analytics jobs. The more data that you have, IoT data that you have, let's say you want to train data science or machine learning models, then you go for big tables, right? If you want to go for the gaming applications and you're generating, it is generating NoSQL, some unstructured data, you go for Firestore. So depending upon your suitability, you will have to select these particular NoSQL database options. In there is one more thing that I can specify in Firestore mode. Basically, here you get strong consistency. So I should not be writing strong consistency directly here, but the native mode, that is the Firestore mode that you have here, you get the strong consistency. Whereas in data store, which earlier version, it is still eventual consistent. Okay, then in here it is called as kind and entity. These are the, this is the way data store mode stores the data. Kind is like a table. Entity is like a row in that. Okay, whereas the Firestore, which I showed you, is a document oriented. It stores in a document, and collection of documents is called as collection here. Collection is like a table. A document is like a row. Okay. Then data store basically can scale to millions of writes. If you want good writes per second kind of performance, you have to go for data store, and for Firestore you have some limits to, I think, 10,000 writes per second. Okay, so there are some of the differences. Okay, with both these modes, but both of them are the modes under Firestore as a one NoSQL database tool or the service. Okay, so I think that's all about the Firestore also, and quickly I'll cover memory store. So do you know what is the fastest type of database in the world? Okay, that is memory store. Fastest type of database. Okay, that is nothing but the memory store. Why it is fastest? If you compare that, on the in your laptop, right? You have hard disk, you have RAM as well, right? RAM also has its own storage, right? Let's say, or on your smartphones, right? You also have an external, disk, right? Within your, within your smartphone, and it also has a RAM. When you open a particular app and you minimize it, and then you reopen it, so all the tiles of that app, let's say you open Amazon Prime, right? So whatever is being run earlier before you minimized it, that is still there, right? So it is basically storing that particular state of that particular application in your RAM. That is why the RAM is the fastest one, right? So if your database also can sit directly in the RAM itself, right? So your entire database or entire data sits in the RAM, then that is nothing but your in-memory database. What is the fastest type of database? It's called as in-memory database. What are the examples? You might have heard about Redis. You might have heard about Memcached. Okay, these are in-memory databases. Examples of in-memory databases. What Google Cloud has done is GCP has managed versions of the above two databases. Okay, what they have done is they have taken Redis, they have created their own managed version of Redis. They have taken Memcached, they have created a managed version of Memcached, and they both are available for your use as under memory store database. Okay, they are very fast in response. Everything is within the RAM. Okay, no disk involved. Disk is not required. Okay, even the queries and the updates and everything happens within the RAM because the database itself is in the RAM itself, right? So if I show you, this is where it is required. Okay, you need to know the use case where it is required. It's required, or it is best suitable when you want something like live scores, right? Let's say live scores, live leaderboards. You might have seen some applications in mobiles also where you can play, and there are globally people are playing, and then it shows keep on changing the leaderboard, who is the first, who is the second, right? So all these ranking and leaderboards also you want to maintain very fast, right? So these kind of things which are small enough to fit in your memory, but you want very fast response, then you go for the memory store kind of solutions. Also, there is one more thing where caching required in the session management of your website. So you can use session management in for that you can use memory store, right? And I already told you, right? Websites like leaderboards and all those things where you want faster responses, faster state change of states, right? So that's where you can go for memory store. So if you go to memory store, let me show you. So memory store, if you go to memory store, it will ask you for those two options. Let me enable that. So now we are left with one database. Shall we continue? That is file store, not fire store, but file store. Shall we continue and finish that today? Because it will keep on piling up, and in the next session again we will have uh, we'll have to spend 30 minutes minimum for file store otherwise. SAP HANA, yeah, that's a good example. Yes, that is also in-memory database. Yes, thanks Shrey and Nahid for highlighting that as well. So what about file store? Shall we continue for 20, 30, 20, 25 minutes? Is that okay with everyone? Who are from other than IST time zone? Can I get responses? If there is no one else, then we can continue, I would say. But I leave it to you guys. If I don't see anything, Edureka US CST time. Yeah. Uh, Social media, Bigtable. One second. Let me read the questions. Bigtable can access millions of requests per second since it does not store data based on the keys. Yes, if you want low latency and higher throughput kind of solutions, NoSQL is the way for you. Okay, is the solution for you. Can we store social media? Yes, you can store social media for. You can use that for Bigtable. Yes. Firestore is costing. How is the costing done if do not create an instance? So for whatever the serverless solutions that we have, right, we do not create any instance, then the costing will be entirely upon how much data you fetch, how much data you store, right? We'll have to see the pricing calculator for Firestore to get the exact calculation, but since there is no instance, doesn't mean that there is no storage. Basically the storage is being handled by Google Cloud, and whatever the data that you store, you will be charged for that. Similarly, BigQuery is also serverless, okay, but BigQuery will charge you for storage and fetching the data both, right? So similarly, Firestore will also be the same way. So for costing, doesn't have to be always the instance has to be there, okay? So it's just that even the serverless will have the costing attached to it, but for the exact things, we'll have to see the pricing. Strong consistency, acid, eventually consisting base is the case. I'm not sure whether they call it as base, but acid is that might be a terminology being used in the community, but acid is the prominently being used because acid is nothing but atomicity, consistency, integrity, durability, all these I think integrity or isolation, right? So these are nothing but the concepts which a relational database has to adhere to. So consistency is one of them. So similarly, I'm not sure base is the correct term that is being used. Mm, for gaming, should I use Firestore or Cloud Spanner? You should go for Firestore, okay, for gaming. Cloud Spanner is basically when you have lot of relational data which cannot sit in your Cloud SQL. You want horizontal scalability or up to petabytes, right? That is where you go for Cloud Spanner. Generally, for the gaming applications, the data is in a unstructured way. That's where you can go for the NoSQL database like Firestore. Spark is also in-memory computation, I think. Spark is a processing framework, which is in-memory processing framework, right? But it requires your machines, slave machines, to that's a computation, right? We are talking about the database which is sitting inside the memory. Okay, so yeah, SAP HANA can be an in-memory database. Yeah. Any other questions? PSC time zone, I'm okay to do it. Okay, but you're okay to do it, right? So let's continue then with the file store and finish all the storage services that we have. So this is very simple, and basically, let me see if there is any diagram. Yeah, let me copy both of these diagram and we'll discuss about these in file store. So just forget the other one for now. So if you have not personally, we don't use the network file system, but in the company level or at the enterprise level, generally we have something called as shared network drive. Okay, so how it is configured at the company level is basically you have some workstations which are connected to LAN or your Wi-Fi, let's say company Wi-Fi, and you have a NAS server, which is network attached, storage server. Okay, it's maintained within your company itself, and it's a network drive of your company. What you can do is now coming to this one, you might have done this, I'm not sure, but if you go and you can right click on your this particular, go to my PC, right click, you can say add a network location. It will ask you for a custom location, let's say, and you can just put a network address here, address of your network drive. What will happen is it will appear one more drive over here, just like this one, just like this one, right? A Z drive. Z drive is a shared drive, and this has 195 GB of space. This is being used by all the people or of all the employees of your company, right? So that Z drive here, which is nothing but a shared location, which is nothing but a NAS server of your company. Okay, but if you want a Google managed service for the similar one, that is nothing but Google managed service of service for NAS is nothing but file store. Okay, file store will work the exact same way. This is called as mounting, right? We have mounted this particular network path on my new drive, that is Z drive, right? On my Z drive I attached my network path. Similarly, you can attach your file store mount point on your, let's say, VMs. Let's say you have multiple VMs, right? In your GCP, you can share the data using file store. Basically, this is to you being used as a shared drive by multiple employees or multiple Windows machines. Similarly, file store is nothing but the managed version. You can also use the same to be shared as a network drive by multiple VMs in GCP. Let's say you create. Let me show you what I plan. I mean, there is nothing much to be discussed in the theory part. Let me directly jump onto the demo. What we'll do is we'll take this one. What we will do is we will let me take a pen. Okay, so the same way, instead of this one, we will create file store. Okay, we'll have a file store. So that will also have some mount details. We'll get some mount details of that. Okay, then for this particular machine that we have, right, we will create a VM. Not just one VM, we will create one and two. Okay, then these mount details of this particular mounting that we have done here. Okay, I'm sorry about that. So the mounting that we have done into Z drive, similarly we will do the mounting on this machine at some path. Okay, we will create a directory or a folder, and we will mount this path here to with this directory. Again, similarly, we will create one more directory, and we will mount the same path here also. It's the same path we will mount, and what we will do is we will create one file here, file.txt, in this particular file. So automatically it will be synced with this file store. And since the same mount path is also mounted on another VM, I should also be able to see the file here. Hope that is clear. So the same way this also happens on your network drives, right? When you create a file in a shared drive, all the people who has access to this shared drive, they also can see those files, right, on their laptop. Similarly, we will do the same way using file store. Okay, there is nothing much difference here. So let me quickly go to file store. This is the file store. So don't get lost, okay? They will be creating different things here. So that's why I just first thought of explaining you the plan by taking this example. First of all, we'll create the file store instance. Okay. For that, I need to enable the API that I'm going to use this particular service. Okay. Now I can create an instance. I can say I can give any name, NFS network file system server. Then I can take whether I want to do some basic stuff, enterprise level stuff, or high scale stuff, depending upon different capacity. I'm okay with basic right now. Let's do SSD or HDD, anything is fine, right? HDD is also fine. 1 TB of minimum storage that we can take. Then region, we can take any region, and US Central 1, fine. VPC, I have to select where I want to keep this. This will be only visible in that particular VPC perimeter. So I'm selecting default, and I want automatic IP allocation. That's fine. And this is where I want to give a name to my file store mount point. Okay. So let's say mount point. I can say Edureka file system, file store mount point. I'm just giving a name. Okay. It must be 1 to 16 character. Let's say remove this file store mount point. Okay. Grant all the VPC. That's fine. Let's create. So meanwhile, when this gets created, we will have to let's create two VMs, right? Let me create two VMs. Couldn't create. Okay, let me first check what is the issue. Oh, it did not tell me here. Neither here. Let me try once more. NFS server 1 basic HDD 1 fine, center 1 fine, VPC default use, and let's say Edureka FS and create. What is the error? Could be that error which I told you, right? When we keep on creating the resources at the same location, same region, it might stop you from doing that for the free tier account generally. Otherwise, we'll create in another region. That's also fine. Let me just check whether is it. Yeah, it is creating now. So let me duplicate this window, and parallelly we will create, or we can do one more thing. We will create the instances VMs using command. Okay, so gcloud, the command is compute instances, and first of all let me see the list of instances. I don't have any VMs running, right? Let me go to VM page. Okay, I don't have anything, right? So this time we will create. Let's give it a name, central 1 or US central 1, let's say, right? Because I'm going to create two machines, and what I need to do is minimum thing is zone, right? So US central 1 hyphen A That is my zone. Machine type can be anything, that's fine. So that's the minimum. I think we have seen once, right? Zone is the minimum thing that we have to give, and the name. With that name, it should create one VM. Okay. Then let's create one more. Let's create this in Europe. So fine. For this, I need to give Europe Central, say 2 and A. Let's try this. Is my file store ready? File store, I'm sorry. Still being created. And my both VMs are ready. So let me refresh this. I should be able to see 2 VMs. Okay, this is my first VM1, and this is in Europe. Okay, then let me just connect them parallelly, side by side we can do. Now what we need to do is, so let me go back to the notes where I explained about this, right? So now we have 2 VMs, right? Now we have 2 VMs, and what I said is we want to mount this path. This is still being created, so we have to mount this path, these details on my local path, right? Some directory I will create, and I will mount this one, and I'll mount this one also in VM2. But for mounting, there is a command called as mount, and mount command is not directly available. I need to install the mounting tool, right? So for that, I'll have to install something. Just that it is very similar to earlier when I installed Apache 2, right? Apache 2 is one more tool for creating a web application. Similarly, for mount also we need some utility to be installed on our uh, on our VMs. So meanwhile, this is still getting created. I think, yeah, that's got created. So first of all, let's do this parallelly. So this is one VM, this is another VM. These things will remain same for me. Sudo su go login with root. Here also sudo su login with root. I'm going to install first. I'm going to update all the libraries or the packages that I have. apt get update is to get my libraries updated first. It's done on both the sides. Now apt get install, and what is that tool that I want to install? It is called as NFS common. Okay, and -y is just that whatever questions it asks, it by default approve it. So apt get install NFS common -y. So this will install this NFS common utility on both the sides. Once it is now ready, if I show you, I am in home Edureka 2708 2020. This is the folder where I'm in, right? So I'm going to create one directory. Let me call it as mount. It can be anything, okay? Mount directory. Okay. So if I do this, I have a directory here. Let me go inside the mount directory. Okay, I am in that particular directory. I'm in a local machine. I'm in that particular local machine, and I'm in that particular directory. Okay, I'm coming out. So I have a directory to mount. Now for mounting my file store to this particular directory, what I need to do is I need to go to this. My NFS is ready. File store is ready. Just go here and copy the mount point. Okay. Now after that, what we can do here is there is a command called as mount, then those mount details, and then the directory. What is my directory? My local directory is this one. So let's see if it is it mounts it. Okay, it successfully mounted my file store instance with the local directory, local folder of this particular VM, which is mount dir. It mounted that file store with my mount directory, local mount directory. Similarly, I'll do the same thing here also. Mount, paste, but I think we have not created any directory on this machine yet, right? Let's create one more here as well. Mount dirs, and then let me mount. Okay. So on the both the sides, I have mounted. So what I have done, if I compare with this one, is I have two, let's say two laptops connecting to the same network location. That's all I have done in the Linux box. Okay, so this is my network location. This is my one laptop or one VM, which is mounted to this location, and this is my drive, like a Z drive, which I have shown you right on the laptop screenshot. So similarly, I have mounted one more here on the another VM also. Now let me go to the first one. Let me go inside this my local directory, and I create one file. Okay, file1.txt. Touch is the command to create one file, right? So if you see here, one file, forget about this, this is internal one. Okay, so file1.txt I have created in this particular path. I have not created anything here, but since this mount path is tied up with this, and this mount path is tied to this particular directory, then I should be able to see. Let me go in mount directory 2 here, and if I do ls here, I should be able to see that file here, because this file I have not created on this particular VM. I have created this file on this particular network location, and since this network location is accessible from other VM also, I am able to see that file automatically here also. Okay, so if I do vi in this particular file from machine 2, let's say vi is to edit the file, right? This is the edited file from VM2, let's say. Okay, then I'm just saving it. Oh, sorry. Okay, let me cat the file to check the contents. Okay, I have edited the file on VM2. Let's see whether it has got edited or not. See, so I have just fired the cat command on the left side in the VM1. I can see it's the exact same file that is getting edited, right? So it's basically one network location being accessed by multiple VMs, right? So it's very much similar to the network address, sorry, the network attached storage that you have, but it's a managed service by Google Cloud. So you can even fire df command to see the mount point details, right? So this is the mount point detail, and this is the local directory where that is attached, right? So, and you can also see the available bytes and all those things. So any questions on all of these till now? Else otherwise we'll go back and take only 5 minutes on to understand when to choose what. Okay, so I have a diagram for that as well. If you have any questions, please post it now itself. Maybe we can take up after our discussion. Okay, so it's very simple. Few questions you have to ask. Okay, so it starts from here: whether your data is structured data or not. Okay, structured does not mean relational. Okay, structured means It can, whether it is a file based kind of a data, it's completely unstructured or structured, right? That is the only simple question you need to ask, whether it is a structured or unstructured. It is unstructured, go for something like file based solution. For file based, you have two solutions. One is a shared file system, which is file store, which we just now seen. Okay, and you have cloud storage system where you can upload the files, but those will be stored as an object, right? And it has uh, you know totally a different use case, which is this is only available within your VPC by your VMs, whereas cloud storage is basically a global one, right? You can give access to any other projects also, and then it will be visible for them as well. It's a global resource that you can create, right? So depending upon what type of file storage you want, you can go for either file store or cloud storage, right? And if it is unstructured, now if your data is structured and you want to do some analytical work on that, do you want to do any analytical work, then you have big data solutions. Okay, big data solutions. So under big data solutions there are two things. One is BigQuery, which we will be covering in actual big data analytical module, but otherwise you have a NoSQL database also, which is big table NoSQL database. If you want a relational kind of a data warehouse, you go for BigQuery. If you have NoSQL kind of database where you need low latency and frequent updates, then you go for Bigtable, because NoSQL databases are actually meant for low latency, high throughput writes and reads operations. Okay, BigQuery is a data warehouse, so where you can keep petabytes and zettabytes of data, right? But for the data warehouse kind of solution, some data analytical stuff you can do use on that particular data warehouse, right? So this is require. This is when you have some analytical work to do. If your work is not analytical, then you can go for either of these, depending upon whether it is relational or non-relational. If you are going for a non-relational, means your what I can say, your schema is not fixed, right? Your schema is keep on adopting or changing, right? Then you can go for file store, right? And if it is relational, and under relational you have tables, databases and all those things, but you want horizontal scalability, you are not sure how big it will grow in the next 10 years, let's say, right? You're not sure, so you can simply go for cloud spanner. Otherwise, you know how big is your database going to be, and that's the maximum you want to stick to the relational database, you can go for cloud SQL. Okay, so even it may happen that I have seen in one of my project that they initially went for cloud SQL, and then they wanted to move away from relational database. So that's where they started using BigQuery. So we then offloaded all the data from cloud SQL into BigQuery. And I have also seen some use cases where people directly go from their Oracle or Teradata kind of data warehouse directly to GCP native solutions like BigQuery directly, without even uh, going to Cloud SQL or anything like that. So for but Cloud SQL, since we are moving to a cloud platform, basically even though you are not dumping your data into relational databases or like Cloud SQL, we can still use Cloud SQL for some other purposes like logging, like auditing. All these things also can be done using Cloud SQL, because on BigQuery there will be some limitations, right? So that is not meant for auditing purposes, right? So for auditing purposes, I would say relational databases are the best, because those are internal to you, right? Auditing of your jobs, auditing of your workloads, right? All those things you can simply do using relational databases. So that's where you can use for Cloud SQL also. If you don't know the scalability for, then you can go for, and you are okay to spend more money, then Cloud Spanner is the best solution because it provides horizontal scaling. Okay. Um, Yesterday you mentioned you will be showing how to okay, how to work on assignment. Oh, I almost forgot on that. But is it okay if we cover that in the next one, because we already passed 35 minutes. Some people are from other time zones. It's too much late for them. So yeah, thanks Gana for understanding. But yeah, I almost forgot on that point, the assignment. Mm, yeah, I can guide you. Basically, there will be some whatever I have seen. Um, but yeah, let's take up later. Do you have any questions, guys, on today's topics? Let's cover that first today. We'll just go to the Cloud Shell. Meanwhile, let me delete the instances. Meanwhile, no questions? No. Okay, I'll have to give zone also. Yeah. Okay, I think no more questions. Then we can conclude. There was one thing, right? Dia, you wanted to take up some questions on the last. Do you want me to unmute you, or you wanna type on the questions? Anything is fine. Uh, so I think we can conclude. Those who want to drop off, I'm sorry to keep you late, guys, as well, from those who are from other regions. But thanks for the supporting. And those who want to drop off, they can drop off. If you have any questions, you can post it. Those who want to have a chat or have a discussion, I can unmute also. Okay. So, Dia, are you there? I think you said you will park some question for last, right? But I think Dia, I don't see Dia in the participants. She might have left already. Okay, Nahid. Yeah, thank you, Nahid. So, okay then, if no more questions, we can conclude. I'm just going to delete all these resources. So even if you practice the same way, you also keep, keep a habit of, deleting these all the resources that you create during the hands-on. Okay, don't leave them, up and running. Okay, fine. So Gana, I'll just check one or two of the assignments, and I'll guide you with how it can be done. Okay, and I don't think anything other than that is pending. Uh, the next one will be GKE. Okay, so if you have some time, just read out containerization and all the basics of containerization, Kubernetes and all. But I'll be covering most of the things. So fine, I think with that one we can conclude. And thanks for being patient for 40 minutes, extra 40 minutes. Yeah, have a nice weekend and see you in the next on the next weekend. Okay, Saturday. Okay, thanks guys. See you. Bye.